sound?
10, 20 hertz, 10 hertz to 10, 10 kilohertz.
Yeah.
And so we heard humpbacks, fin, a lot of fins.
Yeah. They were vocalizing the
Oh,
fins,
fins. In fact, I've got one of my slides. You can hear, I have to play it 10 times, but you can hear the turbine very loud, going around, and then all of a sudden a fin wheel starts in the middle of the 1 minute.
Wow.
Yeah,
Interesting. Yeah.
minute and a half.
Do you have any sensors out there permanently? Or?
No, but we've been going out seasonally. We have another. We just recovered most of it. We've had him in for a month at a time, so just continually, recording, and then I smell it again. Yeah. Ah. Okay. It's funny. It is an electronic smell. It smells like,
Definitely.
like,
Ozone-ish or
yeah.
something like a fan is working on some
Yes.
unit.
It's not my laser.
Hello, everybody. We're going to start. Can you hear me all right? Hello, everybody. We're going to sit down. Thank you. Okay, here we go. We're going to start again. So, can you hear me all right? Can you hear me? Okay, so, can you hear me? Okay. So, back again. How was lunch? What? Very good, good. What was your favorite sandwich? The Doritos. Good, good. Like that MSG. Okay, Janet Friedman, you're in the way back, right? Okay, Janet, if you can't hear us, all right, you get to stand and scream and shout, okay? All right? Anybody over here want to volunteer? Reed Porter, okay, you too, okay? If you can't hear, please scream and shout. Okay, another reason why John King is going to scream and shout as well is if you smell a little something, right? John King is our today's fire marshal. And, yeah, exactly. And he's very good at smelling. And so we have it under control, that smell. The famous last words, we're the government, we have it under control. So we are, if we smell something, we are taking a look at things and all that good stuff. But welcome to URI, and there is a bond issue for GSO to get a good new auditorium. It's coming up, so you can vote for that. Okay, so I'm going to pass it on to Amy.
Good afternoon, everyone, and welcome to the Marine Mammal Panel. My name's Amy Moses. I'm a Vice President and the Rhode Island Director of the Conservation Law Foundation, a New England-wide environmental advocacy group that has been around for over 50 years. We've already heard about marine mammals this morning from Jeff and Grover and Catherine, and we are going to take a deeper dive into those issues this afternoon. We've got a great lineup of speakers here today. We have Rick and Lauren from AIS Observers. Scott Krause is here from the New England Aquarium. Professors Jim Miller and Gopu Padi from URI Ocean Engineering. And you can't see her, but Julie Crocker is on the telephone and will be appearing via WebEx from NOAA Fisheries. Everyone is going to be making a presentation today, so we appreciate your patience in advance with the technology. And before we start, I just want to recognize my predecessor, Trish Yadley, who many of you worked with at the Conservation Law Foundation. She was really at the forefront of the marine mammal advocacy with the Block Island Wind Farm on the ground here in Rhode Island, and myself and many others are grateful for the important work that she did. So with that, I think I'll turn it over to Lauren. It should come on.
Can you guys hear me in the back? Hear that? My name is Lauren Wall, and I work for a company called AIS Inc. We're based out of Marion, Massachusetts, and I'm calling to talk to, talking to you guys a little bit today about the work that we did with the Block Island Wind Farm, providing protected species monitoring services. I can stand on that side if you want. Yeah. Okay. Is this a little better? Yeah. Okay. So anyway, just to give you a little background on AIS, we provide certified and trained monitors and inspectors for various maritime projects. So protected species observers for offshore wind industry and various other construction projects. Federal fisheries observers is another big one of ours, and we've worked with the State Division of Marine Fisheries and various other maritime projects that we provide field technicians for. Okay, so a couple of things I'm going to go over today are just talking about the protected species monitoring overview of the Block Island Wind Farm and how we were involved. So we worked closely with Deepwater Wind to develop an environmental awareness training. We also worked with them to develop environmental compliance methods to make sure that we adhere to all the permits that were issued for the project. I'll talk a little bit about how the PSO were involved in the overall construction and compliance monitoring, and then some of the challenges that we faced as part of this project, and then some suggestions for future projects. So the environmental awareness training was developed and given to all individuals working offshore on the project prior to their start. Covered the following topics. So we talked about environmental compliance tools. A permit environmental compliance plan was developed. And binders containing all this information were placed on all construction vessels. That included all the permits that were issued as part of the project and plans to make sure that we adhere to all those, so everyone had access to those on the vessels. We also educated everyone working on the project on the PSO role and the mitigation measures that might be needed if protected species were sighted close to construction activity. We also talked about ship strike avoidance measures following the NIMS whale watching guidelines, and also gave everyone some marine mammal identification training. Basically, Deepwater Wind wanted the everyone is responsible approach, even though PSO were sort of primarily responsible for it. They wanted everyone to be in the know, and they developed, you can see here on the right-hand side, an opportunistic sightings log. So that was actually issued to all folks working on the project. So if they cited something there where a PSO wasn't available, they could write down some of the similar information that PSO would. So some of the environmental compliance method Deepwater Wind had to implement was a hydroacoustic verification program to verify the sound propagation that had been modeled prior to the start. So in 2015, there was real-time verification of the 180 decibel and 160 decibel isopleth. In 2016, during the cable installation, they verified prior to the start of the project the distance to the 160 decibel isopleth, and that was because of the dynamic positioning thrusters used on the cable installation barge. And then the other compliance method was, basically using protected species observers. So these folks were stationed on the highest available vantage points during foundation installation and cable installation. to monitor for protected species. They used laser rangefinders and reticle binoculars, as well as night vision binoculars for nighttime observations on the during cable installation. So just a brief overview of the 2015 foundation installation work. This work was, the pile driving was only authorized during daylight hours, so we actually had 2 teams of PSOs, one aboard the pile driving barge and another on a designated monitoring vessel. They were responsible for monitoring the zones. So these are the 2 zones that we were monitoring: the exclusion zone, which was associated with the 160 decibel isopleth, and that extended to 600 meters from the sound source. The monitoring zone extended out to 7 kilometers from the impact pile driving sound source. So it was a big area, and that 7 kilometer mark was the 160 decibel isopleth. As far as the cable installation, the PSOs were stationed on board the cable installation vessel, and they monitored to this 160 decibel isopleth as well, and that was actually only 21 meters from the vessel, so a much smaller area to monitor. Because they couldn't actually turn the thrusters off, they were required to turn them down as much as possible if an animal entered that zone. And the PSO monitored basically when they left the dock at the start of the project till they got back, because the thrusters were always in use. So a little bit about some of the challenges that we faced during this project. As part of our permit requirements, we had to submit names for protected species observers 45 days in advance of the start of the project. So this meant, we had to sort of take into account ahead of time any potential delays or extensions, and we ended up submitting quite a number of resumes, about 35 or 40 each year, just to have available folks, because, with an extension, you never know who might not be available if the work took longer than initially expected. Another challenge was the long hours, and this was really a project-wide, but with the folks working on there were no live-aboard conditions on any of the vessels, so basically everyone changed on and off with the crew, which were 12-hour shifts, plus an hour to an hour and a half drive or steam to and from the vessel. So, just long days. We had extra PSOs unavailable to rotate for eye fatigue, but that doesn't sort of prevent overall exhaustion working those long days. And sort of right off of that one is data submission. So, and this project was fairly inshore. They still had to submit their data once they returned from land. From the project daily to submit to the agencies as part of our requirements. So on top of the long day, having to submit data, on future projects even further offshore, they might have even more limited access to internet capabilities, just, being out of cell range. There are also some limitations with night vision. We use generation 3, which is fairly good, but it only can see about 350 meters. So not a huge range. Let's see. And then from the PSO monitoring vessel, so I talked about on the foundation installation, we had a specific vessel used for the PSO to sort of circle the pile driving barge to watch out to that 7 kilometer mark. We needed to have a vessel large enough to be able to go out in 8-foot sea conditions, which was what we were tasked with. And we wanted to try and use local commercial vessels, but unfortunately ran into issues with captain licensing and vessel inspection requirements. So we ended up we used a charter vessel, which was used to that thing, but it would have been nice to try and use a commercial vessel. Another challenge, so with that daily transfer of folks on and off both the cable installation barge and the foundation, came at-sea transfers, which are inherently dangerous. There were no injuries, and Deepwater did everything they could and really made safety a priority. They actually spent several days developing a good at-sea transfer plan to make sure that everyone was safe. However, if there were live-aboard conditions, it would reduce 2 things, one being that need for at-sea transfers all the time, and the long days would be minimized, or a little bit anyway. And then the weather conditions, which is always a problem in an area where you're developing a wind farm where it's supposed to be windy, and with it comes waves. So visual observations become difficult in deteriorating weather and conditions. And, they could continue pile driving at up to 8-foot seas, so it made it sometimes difficult. So a couple of suggestions for future projects. And we've actually used some of this technology on projects already since 2015 and 2016 as HD and thermal imaging cameras. So this would allow us to have better observations, further observations at night, and also in low light conditions. So that would be useful if someone wanted to go to pile driving 24/7. And also just live aboard accommodations, which would enhance safety, reduce those at-sea transfers, and also reduce fatigue due to long days. And with that, that's all I got.
Thank you, Lauren. Next up, Scott Krause.
Thanks, I'll stand in front of your laser. Okay. I got too many. I only have 2 hands. All right. So for the last 5 years now, we've been doing surveys over the Massachusetts, Rhode Island wind energy areas, south of Nantucket, Martha's Vineyard, and over to the western margins of the Rhode Island, Massachusetts border. So I'm going to describe those very briefly and give you a little summary of what we've seen and learned. So these are the areas, and this area was added. We started this whole box in 2011, and we added this box in 2012, and since that time we've been flying these surveys over the whole period, at least once a month. In the last year, in the first 4 years, we flew twice a month, except when weather knocked us out, so which happened a lot in the winter. So there should be good power generation in the wintertime. And surveys were random start with 7-mile intervals, and that meant that you could see about, probably 30 to 40% of the area for large whales, and much less than that for smaller marine mammals, and much less than sea turtles. We also, in the first 3 years, did an acoustic survey that was ongoing continuously. We had 9 stations, and these are bottom-mounted hydrophones that record continuously, and we recorded all sounds that we heard, including ambient noise plus all the large whales. And the acoustic detection ranges are estimated from a variety of sources, mostly in the literature. And this indicates that you could hear minke whales out to, a couple of nautical miles. You could hear right whales out to about 8 to 10 nautical miles, and humpback whales a little bit further than that. Now, one of the things that you'll notice over here is you'll see some fin whale detections down here. Fin whale detections, because the frequencies are so low, carry a very long ways, and so you won't see any detection ranges for those because we were detecting fin whales all the time, and you can hear them probably on this shelf 100 to 200 miles away. So it doesn't really tell you much. So these are great tools, but they have some limitations, and one of them is you don't know much about fin whales except that they're always there. What we did was something a little bit different than previous surveys. So the effective strip width for large whales is a little over a nautical mile by the observers. Observers, however, we're using Skymasters, Cessna 337s, twin engine, push me, pull you airplanes. And the problem with them is that the observer's sitting there with his head bashed up against the window and he can't see beneath the plane. So in order to protect the track line, we installed a camera that had this field of view and pretty much protected the entire track line, shooting continuously. Originally we did non-overlapping but adjacent imagery, and then my poor observers spent a couple hundred years just looking at the photographs where there's a lot of empty water, but every so often you get turtles, you get sharks, fish, you get a lot of debris and dolphins and a bunch of different stuff in there. And so one thing that it does is it allows you to be pretty confident that you don't miss anything underneath the airplane. And it also provides a secondary for things like sea turtles, where observers pick up sea turtles right next to here. It actually offers an independent sort of an independent ability, a second way of counting sea turtles in the area that you could combine with the observer data too if you wanted to compare the two numbers. So what do we find? Well, a lot of surveys, and this is combined across 4 years, and you can see some pretty clear patterns. Fin whales really peak in June, and the numbers sort of, they come in April, and they usually leave sort of mid to late August. Humpback whales do something very similar, come in a little bit earlier and leave a little earlier. And minke whales are pretty much the same as same as the fin whales in that early period. And right whales are a little bit different. Right whales arrive in January, and they tend to leave around May. But here's something really interesting that everyone should be paying attention to, because there's a lot of discussion about using passive acoustics to monitor marine mammals. And here's the deal. The marine mammal data from the acoustics showed actually the presence of animals a lot more frequently than we expected from the aerial survey. And we're working on some analyses right now that indicate that when you have above a certain level of abundance, you get both very high concurrence between marine mammal sightings and marine mammal detections in the acoustic system. But when aggregations diminish to a certain size, we don't know exactly what that is, but it's probably just 1 or 2 animals, might be very few animals. You'll still hear sounds. These are just presence information, right? This is not the absolute number. When you hear a sound underwater, it could be one animal calling 100 times, or it could be 100 animals each calling once. You have no idea what the absolute abundance from the acoustic data is. So one thing that we found is that right whales were present much more frequently, at least the sounds of right whales were present much more frequently than the observer data would indicate. And it was actually verified this year in 2017, we were doing surveys across this whole period in the same area that this survey was done in. And our team cited right whales in May and June and July, and again in September. Not many, 1 or 2. I think there were 6 or 7 in this period. But the point is that there's some variability from year to year, and there's a high degree of variability between the sightings data and the acoustic data, as you can see down here. We also correct for effort, because if you don't look, you don't find. So correcting for effort is critical to understanding the distribution patterns of animals. So if you lived in Massachusetts and we're looking at Cape Cod Bay, because of all the whale watching, you'd have a huge hotspot on Stellwagen Bank from all the whale watching sightings. But in fact, if you calculate out the sightings data relative to the amount of effort that people spend looking, you discover that, well, humpback abundance is high there, but it's also high in these other places where people have looked less frequently. So we correct all of our sightings data for effort, and it looks like this kind of messy, blotchy red stuff. But it does give you a sense that for right whales, you get this spring and winter distribution in this area here, and nothing or really virtually nothing in summer and autumn. And if you look at all the endangered large whales, so that includes fin whales, sei whales, sperm whales, right whales, and I don't know where humpbacks stood. I think they were endangered when we started, and they're not endangered now, so go figure. But at any rate, you can see that there's quite a much broader distribution, and that's largely because fin whales and right whales don't feed on the same things. They don't occur at the same time, so they're spread all over the place. So this is less informative than looking at this on a species-by-species basis. And from this data, you can also see on an annual basis that this zone is kind of a line right through the wind energy areas. To the north of this is primarily where right whales are found. And in the wintertime, it's much more detailed, much more up in here. For this year, as I said, it's been a little bit different. Right whales, again, we had June, July, and 1 in September. And the rest of the animals tended to follow the general distribution patterns and occurrence that we saw in the previous years, with the possible exception of this funny the fin whales seem to have shifted to the right or later into the year. They were much more prevalent earlier in the earlier data. But here it was real peak in July and then not much in August. And the humpbacks really peaked in August, which is not the case of what they did in previous years. So one thing that is important from this long-term data set is that it's very clear there's a lot of interannual variability. And as those of you who've been paying attention, the climatology in the Gulf of Maine and the surrounding waters is changing faster than anywhere else in the North Atlantic. And so we expect to see shifts in distribution because there are going to be shifts in prey species and shifts in the oceanographic conditions for each one of these marine mammals. This is also the 2017 data, and you can see distribution patterns have pretty much stayed as we expected from the previous years, with two exceptions. This little cluster of annoying little right whales playing around off the beaches of Nantucket in the summertime, and there were 7 of them, I think. And then out here, we also had a cluster of a few right whales. I think this is earlier in the spring, which was a little bit unexpected, although in 2010, before we started our earlier surveys, there was a cluster of right whales just about here. There was almost 100 animals for about 6 weeks in April, May, I think. So these guys have extraordinary adaptive capabilities, able to move around from place to place, and they can take advantage of very ephemeral but very dense food sources, and so we can expect to see these kind of events in the future as well. The rest of the species, humpbacks, all over the place. The finbacks surprisingly focused over here more. Who knows? Sei whales, which are, they can swing both ways. They can eat fish, they can eat plankton. So they're actually much more adaptable than some of the other animals. And minke whales are everywhere. Okay, so these are some recommendations we made at the end of the first 5 years. And I will say that the Mass Clean Energy Center, which has been supporting this work for all this time, and the Bureau of Ocean Energy Management is now supporting some oceanographic studies. And the reason for that is that one of the questions that will be asked, especially in the face of climate change, that as climatology changes in these areas and whales move around, the first question that some people are going to ask is, well, did the wind farm do it, or was it the climatology or the change in prey species? So it was really important for us, particularly with regard to right whales, to get a handle on what the heck they were eating and what the conditions were that supported that. So that's what that's about, and that study has just completed its first year. And I will say that in all of these cases, there has yet to be a well-designed, you have to remember that the European wind farm experience is not like anything we're going to be dealing with now. There is no controlled understanding of what happens to marine mammal distribution and abundance and how they interact with wind farms, other than harbor porpoise and harbor seals. That's what the Europeans had to deal with. We have to deal with large whales, a lot of endangered species, sea turtles. The Europeans didn't have any of that. So the first wind farm that we put in, the first big one, I think the Block Island is not in the area where there's a hot spot of marine mammals. But some of the other bigger wind farms that are talked about all up and down the East Coast are basically big experiments, and it's important for us to understand that we're collecting data in advance and afterwards to understand if there's any shifts or changes in distribution or abundance. Thank you.
Thank you. Next up, we'll hear from Jim and Gopu.
Great. Thanks for inviting me to, and my colleague Gopu here. We're going to do a little tag team on, we're going to talk a little bit about fish too, in addition to the marine mammals. We're both faculty in the Department of Ocean Engineering here on the Bay campus, and it's going to be a quick summary of our underwater acoustic measurements for the Block Island Winform construction and operation. So next slide, please. RODEO means real-time opportunity for the development environmental observations. RODEO. Mary Boatman's here, and just kudos to Anwar Khan and Randy Gallion at HDR, who's our prime contractor for this work. Next slide. I'd like to, there's a whole bunch of people that have been part of this, including our co-authors, Kathy Vignes-Raposa and YT Lin, Art Newhall, and a whole bunch of people that have made this work possible, and I thank them very much. Next slide. So pile driving operations were carried out in 2015, generated intense, impulsive in nature signals at close range, which radiated into the water and sediment surrounding. Our team deployed a number of sensors, hydrophones and geophones, to monitor the noise at several locations. Closest was 500 meters, and furthest was 15 kilometers. The piles were driven in at an angle, about 13 degrees. That turned out to be important, and we'll talk a little bit about that. So we had, at 500 meters, we had a tetrahedral array of hydrophones, a 3-axis geophone. We also towed, MAI team towed a towed array of hydrophones. That actually became very, very important for some of the range dependence of the pile driving. And then further on, we had vertical arrays at farther ranges deployed by Woods Hole Oceanographic Institution. Next slide. So this is, we actually, the bottom line of the pile driving was intense, but it was about what we expected. If you could play that, this is at 7.5 kilometers, some acoustic data. Nope. And that went on, we could play that for a long time, but it wouldn't take up time. But, okay, we can go. No, no. No, no. Stop, and then hit, yeah. Nope, not that. No. So next slide, please. So this is a summary table. The 500-meter sensor was right here, one of them. This is underwater dB, which is about 60 dB more than air dB. So this was about what we expected, and as you go further, this is range, it dropped down, and that was expected. What was unexpected was on different days, this is towed array data, we got different levels. And it turned out, we think, that it's due to the fact the piles were driven in at an angle. In some angles, the sound was propagated right down the channel, and others, it was driven into the seabed. So that's an important issue. Next slide. So we deployed a similar suite of sensors to monitor operations. And this, I'm going to talk about the December 20th to January 14th of this year. Pretty much the same equipment, except now they let us get a lot closer. So our boats, well, we didn't touch anything, though. We didn't. Next slide, please. So this is the only thing we're able to detect from the wind farm operations. There turns out to be a very low level. This is December 26th, about midnight local time, so not many fishermen out, but there were a few. And this line seems to be from the wind turbines. We can't really detect anything else. So this is a vocalizing fin whale. The fin whales were everywhere. I mean, almost all the time we had fin whales. Next slide. So this is here's a spectrogram. So this is frequency, this is time. And Gopu, if you could play that right here. If you could just slide, yeah. Yep. And we sped it up 10 times. You can just barely hear this. And then the fin. So, yeah, so the bottom line of this is the fin wheels were louder than the, in fact, everything was louder than the wind turbine. And if a boat was nearby, we couldn't hear the wind turbines. That's how quiet they were. Next slide. So now we're going to trade, and we're going to talk about fish.
Yeah, the fish listen to sound in a slightly different manner. Particle velocity is important for fish compared to acoustic pressure. There is very little, unfortunately, there is very little data available on the response and the impact of particle velocity on fish. So that's a bad part. And the idea is to get, so if you can get the data like what is shown here, which shows the sensitivity of the fish hearing. So these curves show the sensitivity diagrams for the fish hearing at various frequencies. But this data is hard to come by. Whatever data available in the form of audiograms, as shown here, this is particle acceleration, and these are as a function of frequency. And anything above this, these curves in this part, the fish will sense it and respond to that. But unfortunately, these audiograms are measured in the lab, and even experts say that, the confidence in those the curves are a little sketchy. So this is data collected during the construction, and this data is collected in water, 1 meter from the bottom. This is data collected on the seabed. And one thing that we notice is that the levels, this is particle acceleration levels, particle motion levels are much higher on the ground compared to particle acceleration levels in water, but close to the ground. So the black curves are the actual measurement, and the colored lines here are the sensitivity of the fish to particle motion. And you can see that definitely during construction, fish will sense the particle velocity, particle motion, and will respond. So these are measured at 500 meters. So this is the corresponding data for the operations. And as you can see, the situation is reversed now. So this is on the ground. This is in water at 1 meters from the bottom. On the ground, practically nothing. The fish will practically hear nothing. On the in the water, this is the 72 hertz sound which Dr. Miller showed a minute ago. So corresponding to that, particle acceleration, particle motion is slightly high. So at that part, some of the fish may sense the particle motion and will respond, but otherwise the levels are, but in general, the levels are much, much lower during construction. This is sound pressure. Again, during construction and during operation. During operation, the levels are much lower, and most probably the fish won't respond to that, but definitely during construction is much higher. So in conclusion, the bottom line is that pile driving will create intense sounds and particle motions, and will affect marine mammals and fish. And during operations, both the particle motion and the acoustic pressure, we think may not have much influence or impact on both fish and marine mammals. So that's all. Thank you. And for any information related to the acoustics, this is a very, very useful source for further reference. Thank you.
Thank you both. Hopefully Julie is going to appear on the screen shortly. Do any of the panelists want to comment or ask a question to another one of the panelists while we're waiting?
I'd just like to, oh, is this on? I'd just like to say that a take-home point of this whole protected species monitoring was communication and education for the whole construction team, so everybody would understand, what our role was during this operation and what role they could play to enhance it. Adhering to these permits is critical to any operation like this, and I'd just like to say Deepwater was very, very in tune to that, and that they facilitated everything they could to ensure that happened. We had over 7,000 man-hours out there watching for marine mammals and didn't exceed any of the permits. And I think that's due to the, the training and the enhancement from Deepwater Wind.
The question was, did you see any whales?
Yes, we did on both portions, dolphins, whales, some turtles.
Yeah, there were actually some species that weren't even expected to be seen, according to the incidental harassment authorization. We cited some sperm whales, which weren't commonly known to be in the area at that time, but likely due to a high concentration of squid in the area. But it was a pretty interesting, little bit of science that came up with it.
Can I also add, right after construction ended about October 30th or 31st of 2015. On November 4th or 5th, we had a single lone fin whale that vocalized for over a day. And we think we were hearing it from 100 kilometers away. It came within 500 meters of our array and then drove 100 kilometers. I mean, it's the most beautiful data I've ever seen. So, and our PhD student, Jen Amaral, is working on it right now, and she's due to give us some results Wednesday.
So you're remaining.
That puts pressure on her. Yeah, and just one other note was that there was a time frame which the construction could take place, the pile driving, and on the second to last day that they were able to drive piles, which they hadn't completed yet, a humpback whale stopped the operation, which I think put Jeff into a little bit of dithers, but we were managed to finish the pile the next day without any interruptions.
Yeah.
Dr. Colley, when you said fish were affected, what do you mean by that? Do they swim away? Do they implode? What happened?
And would you repeat the question as well?
Yeah, the question was whether, when I said potentially fish were affected, what do I mean? I have no idea because there was no ancillary data available how the fish was affected. And that's one of the biggest problems with fish. There is hardly, let's say, very little data is available on the effect of noise as well as particle motion on the fish. And people are working on it right now, so that's one of the areas a lot of work is going on. There are some data, but most of it is unpeer reviewed, so it's hard to rely on that. And I must add that there is no regulations currently for the effect of fish. There is only thing available is some guidelines, which Art Popper and others put together, I think last year, right? Mm-hmm. Last year. So that's the only thing that we can go by. So there is a huge data gap in that area.
A question in the back?
This is also for Goku. So the values that you showed, the threshold for fish, most of those species are included in this area. But my question is, do you have any information about the sensitivity of other life stages of those fish? So larval, juvenile, egg stages, etc. So there's been concern about the acoustic impact on those life stages. I'm curious if you have any insight into that.
Yeah, the question is, in addition to the data that I showed, the sensitivity data, audiograms that I showed, is there any data available on other type of fish or larvae or sea turtles, for example? The reason I showed this data is this is one of the very few, a couple of the very few peer-reviewed data available. So there are other data available, but most of them are conference publications and peer-reviewed. So I'm hesitant to put that up and show that here. So people are working. It's every week you get new publications, but you have to be a little cautious. And as Art Popper correctly points out, there is a lot of variability in the methods by which they collect this data and process it. So unless it is peer-reviewed and vetted, it's hard to use it. So that's one area where there is a lot of data gap. I emphasize that.
This question is for Dr. Miller. In regard to the mammals, the high-level sound of pile driving, the conclusion was that it probably did bother them or affect them.
If it is there.
What did it do? Do we know how it bothered them? Did it swim away? I missed that part you mentioned.
I don't know. The levels that were measured from the pile driving were just about what we expected from European experiences and things like that. The effect on animals is a subject of hot debate and research, including, just like Dr. Patti talked about the fish. We weren't tracking whales, but we were just listening. We did notice during the pile driving that fin whales were vocalizing. So, but I don't know what it means. It's just an observation.
We don't know how far they were.
And we don't know where they were. We're working on systems to track, to determine where they were. So perhaps in the future developments, we could use some of that new technology to track whales. But we don't know what it meant.
So fish and mammals didn't hightail it when the pile driving started, so to speak?
We don't know. We weren't measuring that.
I could maybe add a little to that. From our observations, we had animals heading towards the pile driving at times. They were in that large monitoring zone, but they never indicated any type of distress behavior, some erratic behavior that would indicate that they were being impacted. In fact, the day that the one humpback came into the exclusion zone, they had been pile driving previously, and they were waiting to start up, and again after they stopped, and so I don't know what it means, but.
Yeah, I would just be really cautious about this. And the reason that we we wanted to develop a protocol to testing before, during, and after the Winform installation is because there's a lot of anecdote out there, mostly related to the seismic industry. What's the sound source level on your piles?
230.
So it's equivalent to a seismic explosion, So I think that we have to be very cautious. We can expect quite different responses between toothed whales, which rely upon sound and echolocating for finding food, and baleen whales, which just use sound for finding each other. So I would be very cautious about anecdote because there's way too much of it out there. There's not any good controlled experiments.
I'd just like to add, I caught some codfish there this weekend, and the cod said they love the Winform.
Could you write that in a paper and submit it?
Actually, I have one more. I have a question for you guys, because there was this paper out of Murdoch University a few months ago about plankton kills around seismic, and I was wondering if there's any plankton testing nearby. Not by, I don't know who would have tested it, but anybody testing plankton near the pile driving? Okay.
Yes.
When was pile driving taking place? Was that like November, December of 2000?
2015, it was, it started up a little bit in August, really got going in September, and was finished by Halloween
Of 2015?
of 2015.
My observation was that I wasn't out there at that time, I didn't notice it when the pile driving was going on, but in 2016, we did very well in that area on fluke. But that's 6 months after the fact. So whether the pile driving stirred up the bottom and created a feeding zone, that might have been. But in 2017, my fluke fishing was nowhere near what it was in 2016. So now you're talking a year, year and a half later. But I was just saying, before and later, I don't know, but I noticed a difference from 16 to 17, where 16 was good with fluke fishing. For me, 17 was not.
And was this in the Block Island Wind Farm area?
Yes, yeah,
Right there.
in the towers, yes.
Oh.
They were installing the inter-array cables in 2016, which used the jet plow. They used the jet plow. In 2016, they used the jet plow to install the inter-array cables. So that might have stirred it up.
A lot of turbulence and stuff that had settled, maybe that was a feed for the fish. But 2016 was a good year for us. 2017, a year later, when things had calmed down, was a slow year, at least from my experience.
I guess I would ask you, over the years long before, or even a year before the wind farm, was what you experienced within the kind of variability you saw in previous years?
Because the towers brought my fish to, I really didn't fish the area. I wish I could.
Yeah, I mean, it's the same problem we have across the board. So.
Question in the back?
Okay, I had a question about the 72 hertz signal. Were you able to compare that to operational data from the wind turbines? Know what that was coming from?
The closest, we did not have sensors on the turbines themselves, although we hope to get them on there someday soon. And however, we did take some air noise measurements with an acoustic array of microphones, and we did detect the 72 hertz signal in the air. But we did not detect it through the geophones. So it's probably air. It's coming from the hub, or we're not sure yet.
Yeah, I mean, it's a pretty high frequency compared to the blades.
It is.
Passing the towers, so, yeah, do you know if they were even operating or if they were operating?
Oh, yes, they were operating. So the wind turbines were turning. And in fact, when the wind turbines are turning, we hear the 72 hertz. If they're not turning, we don't hear it.
And that's the only noise that we hear continuously when the wind turbine is operating. So the others are all intermittent.
It's not, the 72 is not shifting.
Not that we can see. The only thing that changes is the modulation, which we think has something to do with the RPM of the turbine. That it seems to be modulated with basically the single blade. The blades just turning around, coming back every 6 to 9 seconds.
Sir?
Well, regarding that airborne noise, sound, we fish near the turbines, and there is some periodic sound that comes on and off. I think it's related to some sort of compressor, and I don't know if there is an oil cooler that comes on and off periodically to back off again. We hear, that's the loudest noise that we hear.
The question was, or the comment was, they've detected some intermittent noise related perhaps to a compressor or something like that, or we haven't detected it. Then again, we haven't looked at everything, all the noise all the time. So I was just talking, we just had a paper last week in New Orleans, and my colleague YT Lin at Woods Hole Oceanographic, when he was looking at the air noise data, also noticed some other lines around 700 hertz or something like that. But that didn't seem to get into the water. So it's a complicated structural air underwater acoustic vibration problem. So we're just trying to get the.
I think we've connected with Julie. Can you hear us?
Julie, can you talk?
Can you hear me now?
Turn it up. Yeah, we heard that.
Okay.
Julie, we're ready.
Ready whenever you are. Can you hear me now?
No?
Maybe it's
I can hear you. Can you hear me? Can you hear me?
Yeah.
Welcome. Okay. We're ready for your
All right,
presentation.
I'm going to hang up the phone now. Okay, thank you. All right, I don't know if you guys can hear me, hopefully.
Yes. Yes.
Can you hear me?
Yes. She can't hear us.
Hey, Julie, we can hear you. Go ahead.
Okay, great. Are you able to see the presentation, or am I going without slides? I can go either way.
We should be all set.
All right, great. Sorry about that, and thank you guys for accommodating me remotely, which is always a bit of a challenge. Julie Crocker, I'm with NOAA's National Marine Fisheries Service and the Greater Atlantic Regional Fisheries Office and our Protected Resources Division in Gloucester, Mass. I'm going to talk very briefly today about NIMP's role in the in regulating offshore wind development, specifically for marine mammals. So I've got just a handful of slides. I won't bore you to death too much with regulatory gobbledygook. See if I can get my slides to advance. Okay, so there are two laws in play when we're considering the effects of offshore wind projects on marine mammals, the Endangered Species Act and the Marine Mammal Protection Act. I'm going to talk very briefly about how these apply to offshore wind generally, and then touch quickly on how they interacted with the Block Island permitting process. So the Endangered Species Act provides protections to species listed under the Act and critical habitats designated for some of those listed species. One of the relevant sections of the ESA is the Section 9 of the ESA, which prohibits take of listed species. And take is defined very broadly. It includes injury, mortality, harm, harassment, basically anything that you're going to do that's going to disrupt an animal and have an impact on it. There are ways to get exemptions on that prohibition on take, either through Section 7 or Section 10 of the ESA, which I'll touch on in the next slide. The other relevant regulation is the Marine Mammal Protection Act, which provides protections to all marine mammals in U.S. waters. So some species are protected under both the Endangered Species Act and the Marine Mammal Protection Act, while other species are just protected under the MMPA. Section 101 of the Marine Mammal Protection Act establishes a general prohibition on take of all marine mammals, and there are exemptions and permitting authorities that allow take in certain circumstances. So both the ESA and MMPA are designed to protect the species under those acts, and they set up regulatory processes to ensure that potential impacts are assessed and reviewed, and provide means to require measures to minimize effects and require monitoring and reporting. So
ESA and offshore wind. Section 7A2 of the ESA requires the lead federal agency for any federal agency action that is authorizing an action that may affect listed species or critical habitat to consult with NIMS to ensure that the action is not likely to jeopardize the continued existence of those species or result in the destruction or adverse modification of any designated critical habitat. So this is the Section 7 consultation process that you may have heard of. So at the end of a Section 7 consultation, NIMS produces a biological opinion, which can either make a no jeopardy finding or determine that the project will jeopardize the continued existence of the species. When we issue a no jeopardy finding and we anticipate that take will occur, we can issue a incidental take statement that exempts a certain amount of take provided that certain conditions are followed. And these are called reasonable and prudent measures and terms and conditions. A couple of other sort of relevant notes. ESA Section 7 consultations must be completed before the final agency action takes place. So they have to be finished before any permits or federal authorizations are issued. And consultation is required for all phases of a project. For example, for offshore wind, there would be a consultation necessary for pre-construction surveys, construction, operation, and decommissioning. The MMPA and offshore wind. Section 101 of the MMPA allows for authorization of the incidental taking of small numbers of marine mammals that occurs during otherwise lawful activities if it's determined that the taking will have a negligible impact on the species or stock. And unlike the ESA, where the lead federal permitting agency has to take the lead for ensuring compliance with the law, for the MMPA, the project proponent or the applicant is responsible for obtaining the take authorization. NIMS, when certain circumstances are met, NIMS can issue an incidental harassment authorization, which is valid for up to a year, or a letter of authorization, which is valid for up to 5 years. And similar to the ESA, take authorization under the MMPA is required for all activities that will result in incidental take of marine mammals, including pre-construction surveys, construction, operation, and decommissioning. So next I'm going to talk quickly about how the ESA and MMPA were in play with the Block Island project. So for the Block Island project, the Army Corps of Engineers was the lead federal agency for the ESA Section 7 consultation. NIMS issued a biological opinion in January 2014, and it was revised in June of 2015. It considers the effects of project construction, operation, and decommissioning on right, fin, and humpback whales, as well as listed sea turtles and Atlantic sturgeon, which are listed under the ESA and occur in the project area. The project came to NIMS with a number of mitigation and minimization measures already developed, and we considered the effects of the project with those mitigation measures in place. Those, as you've heard about already from some of the previous presenters, some of those mitigation measures were designed to minimize exposure to underwater noise and minimize the risk of vessel collisions, and included seasonal restrictions, exclusion of monitoring zones, soft starts for pile driving, observers, daylight only pile driving, ramp up procedures for survey equipment, and dedicated lookouts on vessels. Similarly, for the Marine Mammal Protection Act, there were a series of incidental harassment authorizations issued, both for the transmission cable and for wind turbine construction. Both of those IHAs considered or exempted the take of level B harassment, which is acoustic harassment of 9 species of marine mammals due to noise exposure during either the construction of the wind turbines or the installation of the transmission cable. Both IHAs required measures to minimize noise exposure, including ramp up and observers, and minimize risk of vessel strike, including a 10-knot speed restriction, as well as monitoring and reporting. And I just will leave you with the slide, my contact information, because I'm not going to be available to, to chat between presentations, and also that more information on the Section 7 consultation process and the Marine Mammal Protection Act permitting process are available online, as well as copies of the biological opinion for the Block Island Wind Farm and copies of the IHAs that were issued as well.
Thank you, Julie. If I could ask,
So that's all I have. I think I'll try to answer questions to the extent that we can get them to me.
okay. Does anyone have any questions for Julie while we have her? Sir?
Yeah, Jack Clark from Minnesota. Given the population levels of North Atlantic right whales, around the 450 range, might I assume that there's no such thing as an incidental take?
Okay. The question is, given the population level of the North Atlantic right whales, is there no such thing as incidental take?
So I'll try to answer that sort of in two parts. So incidental take by definition is take that is anticipated to occur as a result of an otherwise lawful activity. So it's not the purpose of the activity, but it's going to result. So under the Marine Mammal Protection Act, we can exempt incidental take of small numbers of mammals that would not have more than negligible impact on the species or stock. And both under the ESA and the MMPA, we consider a variety of types of take. So I would agree that we would have grave concerns with any activity that would expected to result in lethal take or serious injury of right whales. But typically the type of take that's being considered for these offshore wind projects is temporary acoustic disturbance. And we would consider what the impact of that temporary acoustic disturbance would have on individual right whales and consider what the consequences would be to that.
Any of the panelists have a question for Julie? Okay. One concern we hear quite a bit in the environmental community is that it's wonderful that we have these 5 beautiful turbines, but there are a lot more coming in the near future. And I'm wondering if any of you could speak to lessons that you learned from this one project and what we can do going forward to be cautious and mindful of the cumulative impacts that we anticipate.
So you're breaking up a little bit. I didn't get the whole question. All I heard was cumulative impacts.
Oh. Yeah, there are. We have the 5 turbines now up and running, and there's a lot more coming soon. So if you could speak to concerns around the cumulative impacts of what we're about to see.
Sure. So I think there's a couple of challenges there. One, as a number of other people have mentioned both this morning and my fellow panelists, is the difficulty of monitoring impacts in a changing environment, and given just natural variability and some of the other climatic and other changes that we're seeing in our environment, understanding what the impacts of any particular project is difficult. And then trying to understand how the impacts from one project may translate on a much bigger scale is a real challenge, and something I think as an agency and as a community that's looking at the impacts of offshore wind and other ocean development activities, I would characterize that as one of the real challenges facing us, is understanding how both to scale up impacts to large single projects, and then understanding what the cumulative impacts of multiple projects along the coast will be.
Thank you. Jim?
So when we did the Special Area Management Plan, Ocean Special Area Management Plan, SAMP, we used a lot of European data to predict the noise levels from operating wind turbines. And those were gearboxed wind turbines and were particularly loud compared to these direct drive wind turbines. These Alstom GE turbines seem to be much, much quieter. So when we used the concept of a noise budget, we predicted much more noise than I think we would get in actuality. So in terms of cumulative impacts, it's going to, in terms of operational noise, I don't think there's going to be any cumulative impacts because the fish can hardly detect it, even directly underneath the turbine, and you go any distance at all. There's just not going to be, they can't detect it.
And how about addressing the same question, but not during operation, but during construction?
Pile driving is louder.
Scott?
So the agency has actually got a real challenge here because the National Academy just published their volume on cumulative impacts and assessing it, and it turns out that we don't really have very good mathematics for doing this. So when you think about an animal like a right whale, the cumulative impacts that are happening in that population include everything from shipping noise to pile driving to entanglements in fishing gear, and probably a variety of other things. And we still don't have a handle on the actual impacts on the population of each one of those things, never mind trying to combine them together. So it's not just the operational noise, the pile driving noise is probably the most significant thing. I think the best lesson learned from the Block Island work is that operations can be pretty darn quiet, certainly to the level where we're not going to worry about it for marine mammals, and that is great news. The unknowns remain habitat. What happens if you put a bunch of telephone poles in the way of your coyote range? We don't know. In terms of whales in the ocean, this is something that's unknown to us. And the cumulative impacts problem for the agency is one that is a real challenge still. So I'm sympathetic.
Any final questions? Okay. Oh, go ahead, sir. The question was, how will Grover go about permitting a much larger farm not having the science? Do you want to take that?
I guess it depends on what area that we're talking about. When we're talking about marine mammals, it's out of our purview and into somebody else's realm that deals with that issue. But I think that the concept is the same, is that you're trying to take what you know about the environment and the animals, given the monitoring data that's in place, and trying to project that, in this case, not for one farm or even two farms. There could be 3 farms under construction at the same time out there, and trying to understand that and the associated impact from all that. And that becomes a much more complicated topic than just one farm. And I think that's something that we still have yet to work out.
Thanks to all of, I think we need to wrap up now. Apologies. Thanks to all of our speakers for sharing their knowledge and the sights and sounds of the marine mammals. Thank you.
Okay. The panel has taken their seats. I think we're going to go ahead and get started here. My kids' school, they do this. And then you're all supposed to do that. And everybody quiets down. All right. Thanks, everybody, for being here. Now we're on to the Fisheries Science panel. My name is Catherine Ford. I run the Fisheries Habitat Program at the Massachusetts Division of Marine Fisheries, and my team there is responsible for environmental review in part. We do a lot of different things there. So our main role in offshore wind energy development is to weigh in on the documents that are coming out of the developers and the federal government regarding offshore energy. So we do an awful lot of reading and attending of meetings. So this session is about scientific studies that have been conducted in the Massachusetts and Rhode Island wind energy areas to characterize these areas and study potential impacts on fish. So after we hear about the work from this all-star panel, we'll have a short discussion where we talk about what we've learned and where we have to go from here. So our panel is comprised of Drew Carey, the principal scientist of Inspire Environmental, Julia Livermore, the principal marine biologist at Rhode Island Department of Environmental Management, Jeremy Colley, a professor at the University of Rhode Island Graduate School of Oceanography, Kevin Stokesbury, professor of Fisheries Oceanography at the University of Massachusetts, Dartmouth, and John King, professor at the URI Graduate School of Oceanography. So we're going to get started with Drew. And just so you guys know, when I get closer and closer to you, you really need to stop talking.
All right, thanks, Catherine. As Catherine said, in some respects, this is probably the panel a lot of you have been waiting for. What do wind turbines do to fish, after all? So we're going to begin to unveil some of that information this afternoon. But I do have to warn you, we don't actually know the answer yet. Sorry about that. But I do want to start out by saying that I would agree with Chris Brown that the Block Island Wind Project and the fish information that we've collected in relation to it is unique to the Block Island Wind Project. And it does not provide a template for all future projects, but on the other hand, there's a lot of tremendously useful information we can gather from it. So we don't have a lot of time, each of us, but I'm going to focus on just really two things. How we designed and have been conducting two different surveys. There's a Demersal trawl survey and a lobster survey. So I'm going to try to cover both of those. A little bit about the design, some of the preliminary results, and then some observations from that. Did I jump ahead? Yes, I did. All right. So this is the design of the Demersal trawl survey. Both of these studies have posters in the area for the reception this evening, so feel free to go over there. I also wanted to mention that I should have had an acknowledgement slide. I think I've counted at least 15 people in the audience who've been either directly or indirectly involved in this. But some of the folks who are involved will be available during the reception if you want to find out a little bit more detail. I'm just the spokesperson. So this has been conducted on the Virginia Maries, Rodman's trawler out of Point Judith. I think you pay attention to this line on the bottom. This is really important. What's particularly important about this study is that as far as I know, it is the most extensive fishery study of any wind farm in the world, in the sense that you'll notice there's 2 full years of baseline data collected before any construction activity. So the timeline at the bottom shows you when the construction begins. The first red line is roughly the period of time that Jim Miller was referring to the pile driving. The second red line has to do with the actual placement of the turbines on top of the foundation. So those are 2 periods of activity, very intense activity, a lot of boat activity, and a lot of varying levels of noise, as well as disturbance of the seafloor itself. So we are still conducting this survey, so that's why I can't give you the answers. It continues through September of next year. At that time, we will prepare and release synthesis reports on both these studies, where this data can be compared with data, regional data, and you'll be hearing about some of that other regional data a little bit later. 3 study blocks. There's the reference area to the south, due south of Block Island, the reference area east, often part of what's called the east ground, and then what's called the APE, or area of potential effect. So this was an area that was blocked out before the turbines were put into place, just an area that we knew from the whole design of this study was developed in collaboration with commercial fishermen, the HAB, the FAB that Grover has discussed before. So many, many voices were involved in putting this together, as well as the design, vetted by a lot of other scientists. So the APE was an area that we knew was trawlable, as well as these 2 reference areas. So that's a very key element to this study design, is these were areas of the bottom that we knew from logbooks could be trawled. That's one reason why other projects in the future may or may not include trawling as an element of discovery of the fish use of the site. It may be trawlable bottom. It may not be the most appropriate way to investigate them. So use an otter trawl, same as used in NEMAP and other studies in the region, so that we can compare the data. We looked at existing regional data, did a lot of power analysis to try to determine how we could design this. So 2 years before, 2 years during, and 2 years after construction. So this is only one slice of the data. There's many, many different ways of looking at this data, and I apologize if this makes your eyes go a little bit crosswise. Basically, any symbol that is filled is during the baseline period. Any symbol that is open is during the construction periods. So you'll see there's no post-construction data here because this stopped in the end of the summer in 16. We have the other data, we just haven't processed it all yet. So the important thing to know is that in this kind of a plot, the distance between any 2 symbols reflects how similar they are. In this case, we're just looking at the composition of the fish community. So we have lots and lots of different ways of looking at this data. However, what we find is that there's really no very little change in the composition of the community from year to year. And this was also found in other studies that I think will be spoken about in a moment. It's one of the real values of this particular area is, at least at the moment, during this short period of time, we're not seeing dramatic changes in the composition of the fish community. Why that's valuable is that normally fisheries data is very stochastic, high variability in space and time. The less variability there is, the easier it is to see a difference. So the take-home message is at the moment is that as yet we have seen no consistent differences within the area of potential effect, and this includes construction activity and these reference areas. The reference areas are quite different. Reference area east consistently has higher catch. Reference area south appears to have a little bit lower abundance in use. What's really interesting here is that the APE was quite different during construction because we had relatively high catch of little skate and spiny dogfish within the construction area during pile driving. It's anecdotal, I mean, it's scientific data, but it's just a few data points. I don't think it means that they love pile driving, but it is notable that the difference was actually higher abundances rather than low, with the exception of longfin squid. So a quick look at one small slice of the data. 2 other elements of the survey. We looked at condition indexes of these species. Again, we did not see any effect on condition. This is a very important measure, particularly in relation to periods after spawning. We also looked at prey availability. So a number of species, we did stomach contents on them. This is partly to understand those fish that are not well caught in a demersal trawl. So what about the more active recreational species like striped bass and others? Here we found that really the prey availability was not affected by the construction activity. What was interesting was that reference area south actually was a high foraging area. I have to rush on here. The Lobster Survey, again, a near field site, a far field site, again, over 6 years of activity. What you'll see here is that the far field site is on the left and the near field is on the right. Very consistent patterns. It happens that the year of 2016 had particularly high catch, but that catch has come down, and that's also reflected in the industry. So really quickly, I think the lessons learned here is that you really have to balance the fishing community's interest and those of science, and I think we've done that successfully. When you do have availability of other data, conduct power analyses, because we have to really speak in terms of meaningful ecological differences. It's always easy with data to find a difference. The question is how meaningful it is. I think it's important to have site-specific designs, but you have to be very flexible about timing and duration, because these projects, surprisingly, change quite a lot in terms of their timing. As far as the future, really have to engage as broadly as possible. Both CRMC, the SAMP, and Deepwater Wind have done an excellent job of doing that. You really have to manage expectations. So be clear what meaningful results are and not just get excited about differences. It's really important to get some regional data, and the other speakers are going to talk about that, because you can't put these data in context without understanding what's going on regionally. And a little pitch to those who have funding, some regional studies would be really helpful. Thanks.
Hello, everybody. As Catherine mentioned, my name is Julia Livermore, and I'm a principal marine biologist with the Rhode Island Department of Environmental Management's Division of Marine Fisheries. I work in a similar role to Catherine, actually. I do the environmental reviews for both the Block Island Wind Farm and then also some components of the federal offshore wind farms as well. I'm on this panel kind of as the regulatory voice, so I'm going to be explaining a little bit about DEM's overall mission and then how that intersected with the Block Island Wind Farm and how we dealt with the construction of this project. So the DEM's overall mission is to protect, restore, manage, and promote Rhode Island's environment and natural resources to preserve and improve our quality of life. At the Division of Marine Fisheries, our focus is on marine species. We are tasked with researching and monitoring marine species in state waters so that we can contribute to the effective management of all of these organisms. So there definitely is an intersection with the construction, operation, and decommissioning of a project like the Block Island Wind Farm, because if there are any environmental changes caused by that project, that would require us to potentially alter the way we're managing species of recreational and commercial importance. So the way we dealt with this was to incorporate a variety of conditions into the permits that we issued to Deepwater Wind and National Grid, because the transmission system, now called Sea to Shore through National Grid Management, is in partial federal waters. There were separate permits for the Block Island Wind Farm and the Block Island transmission system. But for the wind farm, we issued a water quality certificate, and these are some of the conditions that we incorporated to make sure that we understood what was going on with the habitat in that specific area. Our first condition was that we required an anchoring plan, which was meant to prevent damage to hard bottom habitats. This was something Deepwater provided to us. We approved of it, and then if there were any impacts, which there ended up being a very small scrape from one of the anchors, they had to do a year of monitoring. So that was something we engaged with them on, and I think Fisheries was also involved. I should also note that a lot of these conditions show up in other agencies' permits as well. There was a lot of communication between regulatory agencies in the early planning process. We dealt with CRMC, we talked with NOAA Fisheries pretty frequently, so some of these conditions you will see in multiple permits. then we had jet plowing timelines to ensure that there was no impact to spawning of winter flounder. We had a requirement for long-term monitoring of inter-array transmission cables. So after the cable was actually jet plowed into the ground, we required that they go back and do a survey to make sure that they had achieved their target depth, and then in areas where they hadn't achieved depth, it had to be covered with some kind of matting, not only to protect the cable, but also to ensure that it didn't create a hang that the fishing industry might catch equipment on. And then in addition to that, on the cables, we also required that they do an electromagnetic field monitoring survey, which I believe Dr. King will be speaking about in a few minutes. We wanted to know exactly what the strength of the field was produced by the cable, and then also if it differed by depth that the cable had been buried, or by substrate, or anything else like that that could affect marine species in the area. And then we also included requirements for the surveys that Drew actually just spoke about. This was something I think that's fairly unique to this project. We required that they did a before-after control impact, or a BACI design study. We required at minimum 2 years of pre-construction, 1 year during construction, and 2 years post. And the construction plan changed a little bit, so there ended up being 2 years of construction data, as Drew just mentioned. And that survey design was developed by Deepwater and their consultants, but there was a lot of back and forth between our agency. The fishing industry was involved to provide input to make sure that the data were, number one, going to be useful, that they could be applied to broader studies. As Aileen mentioned this morning, it's for the trawl survey, it's modeled after the NEMAP survey. And then we also required, or we have the ability to require mitigation if there are any violations to our state water quality regulations. Then for the sea to shore component, so this is the transmission cable that goes from Block Island into Scarborough Beach. Similar requirements, we just had timelines for the use of cofferdams, jet plowing, and then also pile driving, just to ensure that species like winter flounder would not be negatively impacted. And then those same surveys with the depth and the EMF were required on the full length of the transmission system cable as well. So something else that's really unique to this project that I think went a long way to create trust between not only developers and, or the developer and the state, but they offered to make payments. They made an agreement with DEM to make payments to our agency to allow someone on staff to spend most of their time analyzing the data that Drew actually just spoke about. So it's those BACI designed ventless lobster survey and the otter trawl surveys. And I was hired in 2015 to fill that role. We also do all of the environmental reviews for any other components of the project. And then more recently, that role has expanded a little bit into the federal sector as well. We're getting input from, we're getting information from all of the developers off of Rhode Island and Massachusetts, as well as off of New York. 2 of these sites haven't been leased yet. But we've reviewed some of the documentation that they've submitted, like baseline characterization survey protocols, cod spawning survey protocols. And then we've also been hearing a lot from our fishing industry about concerns over the New York wind energy area, which is now leased to Statoil. And I think Chris Brown mentioned this morning. This is a really important area for catching squid, and the state of Rhode Island, primarily Point Judith, lands more than half of the coast squid every year. So that could have a potential socioeconomic impact if those squid areas become off limits to our fishing industry. So we took it upon ourselves to do a little bit of research into this, since it is partially our responsibility to make sure that our fishing industry is not negatively impacted by development. So we acquired vessel monitoring system data, and this is a device on commercial fishing vessels that tracks exactly where they're going while they're fishing. There are other data sets that have been used to do socioeconomic studies in the past. For instance, BOEM funded a study using vessel trip report data, and there's nothing wrong with the way that analysis was done, but unfortunately vessel trip reports are not designed to collect information specific to fishing location. They're primarily designed to collect information on catch and effort. So we decided to look to VMS data, which was a pain in the butt to get our hands on, but we were successful. And we plotted out some of the layers, and this is specific just to vessels landing in Rhode Island. We had to use the VMS data in conjunction with our landings data, and we actually had to use the vessel trip reports to connect those 2 data sets. So we did some mapping, and this is a map specific to the squid, mackerel, butterfish fishery management plan, or species managed under it, for the years of 2009 to 2015, and these are only vessels landing in Rhode Island. So you can see that there's definitely a hot spot at this intersection of this lease, so there could definitely be an impact to the fishing industry if the developer chooses to put wind turbines there. But this information is also useful in terms of preparing for construction, in that a lot of additional environmental surveys are going to be necessary. There have been some concerns about squid spawning in the area. So we can look to where the fishermen are catching their fish. They're only going where the fish are. They're the ones that have that knowledge. So we can look to their knowledge to try and figure out where should we prioritize some of our environmental surveys moving forward. So maybe we should be looking for squid mops in that intersection of the lease area. And BOEM actually did remove a couple of these aliquots from the lease area it was too close to Cholera Bank at the request of NOAA. So that was only specific to Rhode Island vessels. We realized that this would be useful to have for some of the other wind energy areas as well. So we acquired information on landings from New Hampshire all the way to New Jersey from the years of 2011 to 2016. And we covered this entire lease area right here. You can see in this, or not lease area, excuse me, this whole area in this bottom map on the right. So I'm just going to show a couple examples. This is all fishing, all landings coming into Rhode Island. Sorry, it's kind of hard to see on this projector. But you can see that there's definitely some hot spots just south of Martha's Vineyard and Nantucket. I think that's mostly squid activity. And then there's kind of another hot spot just to the southeast of Block Island. And if we look at, so that was the whole time period, 2011 to 2016 for Rhode Island. We can also look at it by what species they were catching. So this is groundfish, and you can tell that there's still that little hot spot just to the southeast of Block Island. We can also look by gear type used. So this is otter trawling for 2013, and you can see that same area keeps showing up, and there's a little section just to the west of the Deepwater Wind's northern lease site. So in terms of them prioritizing areas of research moving forward, they might want to focus on pieces of information like this. And this report, we've produced a report. It's going to be going public on the DEM website probably before the end of the month, so the public will have access, and we're trying to figure out a way to share all of the actual raster files so that developers will have access to it and they can use it in planning for siting for the wind turbines. That's it.
Thanks, Julie. Next, we'll have Jeremy Colley.
Okay, good afternoon. I'm Jeremy Colley from the Graduate School of Oceanography. I want to acknowledge my co-investigators, Anna Malick-Mercer, Monique LaFrance, and John King, who are all here today. And I'll just say, today I want to give some highlights of two studies that we conducted. One is a fish biogeography study, another is a ventless trap survey, and I'll just say that all this research was conducted from the comfort of commercial fishing vessels. So I'll read the objectives here for the fish biogeographic study, and we were able to satisfy our objectives, so our objectives are also our findings. This is what we did, and I'll just paraphrase them. But we evaluated the fine-scale spatial structure of the demersal fish and vertebrate community. We assessed the dietary gill structure and the flow of energy through the fisheries food web, and investigated the relationship between fish species assemblage and the benthic habitats. And we did this by coordinated sampling with otter trawls, beam trawls. We did stomach content analysis, stable isotope analysis. We did habitat studies, acoustic mapping, grab samples, and bottom imagery conducted by the King Lab. And I think Monique LaFrance is going to talk about habitat tomorrow, so I won't mention that. So I'll jump right into some of our highlights. And so here's a map of the Rhode Island Ocean SAMP in red. And take a step back to when we started this work in 2009. At that point, there was really a data vacuum in that this area is outside the state remit, and the NOAA Fisheries does sample here, but they sample sparsely because they're responsible for the whole continental shelf. So what we're really trying to do, starting at that point, was really to conduct site-specific information that was georeferenced. And so this shows a combination of otter trawl and beam trawl samples. This is the abundance at these stations. And it's kind of hard to see the spatial patterns, so I'll kind of point them out to you. We found higher numerical abundance in the Block Island Sound area. We found higher biomass and species diversity of the fish and invertebrates offshore. So these are the aggregate data. We can also look at the species composition. We used cluster analysis to cluster the data into species clusters, and they're indicated by the colors and different shapes of the symbols. So we see consistent assemblages of fish, and since we did this over several years, these assemblages seem to be consistent over years. It may be difficult for you to see the labels in the back of the auditorium, so I'll point them out to you. If you look at the inshore communities, the orange and green symbols, these are typically dominated by crabs, lobsters, skate, and silverhake. More offshore would be the red and the blue symbols there, are dominated by sea scallops, sea stars, sand dollars, and yellowtail flounder. So we see distinct communities inshore and offshore in Rhode Island Sound and Block Island Sound. We also looked at the diet analyses, and really what we're looking for here is whether we see a link between the species utilization of these areas and the benthic habitats. So winter flounder is a good example of this because it's a benthic feeder, and the little pie charts show the diet composition of yellowtail flounder. And again, it's probably hard for you to see the labels there because there are many different potential diet categories, but what I want to point out was the difference in yellowtail flounder diet between Rhode Island Sound. Here you see these pies, the pink in the pies, that's dominated by tube-dwelling amphipods and other crustacea, as opposed to in Rhode Island Sound, the brown here, where the diets were more dominated by polychaetes. So the reason that this type of finding is significant is that we're linking the spatial utilization of the fish community to their habitats at relatively small spatial scales, that is, scales of around 10 miles, which is the scale of the lease areas. So it means that the fish aren't just swimming around and feeding everywhere, but there's actually linked to the habitat where they live. So let me move on to the lobster study. So this is the Southern New England Cooperative Ventless Trap Survey. Our objectives were to establish a ventless trap protocol, determine the seasonal and spatial patterns of lobster abundance in this development area, and to conduct 2 years of pre-development monitoring that will allow before-after control impact comparisons to be made in this Rhode Island, Massachusetts lease area. And again, the reason this is important is because you probably know that lobster populations in southern New England are somewhat stressed. They're stressed by fishing, they're stressed by changes in water temperature and shell disease, and it's important for us to be able to distinguish what would be the additive effects of development to the other ongoing stresses of the lobster population. So that's why we did it. What did we find? So concentrate on the lease blocks there because I'll plot the data in that same lease block areas. So this shows the total abundance of lobsters in 2014-2015, where the size of the bubble indicates the abundance. So we do see consistent spatial patterns in lobster abundance in this area. Lobsters are more abundant, Lobsters are more abundant in the eastern part of this lease area block, and the lobster abundance was determined primarily by the habitat type, by the depth, and also by the ambient temperature. To look at the effective temperature, I'll just home in on those 2 red blocks there, shown here. And what's shown here is the distribution of lobster catches over the season in red, the red bars, against the bottom temperature, the continuous bottom temperature record in black there. And so you can see that lobster catches really pick up when the water temperature goes above 50 degrees and continues high after that. The thing I want to point out here is that at these sites, the bottom temperature never exceeds 68 degrees Fahrenheit, which is the temperature at which lobsters begin to be stressed. And so we feel that this offshore area here supports a healthy lobster population, and it may be a thermal refuge for the lobster population in southern New England. Finally, for lobsters, we see a low incidence of shell disease offshore, and this is categorized by none in yellow, moderate in orange, and severe in red. So you can see that there's a low, most of the lobsters have no shell disease, a very low incidence of severe shell disease, unlike what's happening in our inshore waters. So to summarize our findings, we see consistent patterns in fish biodiversity at spatial scales of the least block areas, that is around 10 miles. We see significantly different species assemblages inshore and offshore. So this is really providing that baseline of fish community abundance that Drew was talking about. The diet composition is linked to the benthic habitats. So the demersal fish are linked through their feeding to specific habitats. We found a healthy lobster population with a low incidence of shell disease. And the lobster abundance was consistently higher in the eastern least blocks of that area. And finally, lobster abundance was related to habitat type, depth, and temperature. Thank you.
Next up, we have Kevin Stokesbury.
Well, thank you very much. Thank you for inviting me to speak. I'm actually going to talk a little bit more about the Massachusetts offshore area. And yeah, so here's just there haven't been a whole lot of maps of the entire coastline. So this is what's proposed for wind farm development, and also some of our fisheries areas. A lot of our fisheries are run on spatial management now, where areas are closed and open either seasonally or every few years, depending on the management strategy. And so, of course, the trick is how to make sure that these two industries can interact and both move forward together and both be sustainable. I got involved as Bill and Bruce mentioned on the working group, the fisheries working group in New Bedford, when the dog, this is the offshore lease area it's called, if you squint, it looks kind of like a dog, I guess. So I got involved with that. I was asked to join that group and trying to compile some of the fisheries information. So this is our drop camera survey information, and I'll talk a little bit more about that tomorrow. But it does provide you with a biomass estimate, an abundance estimate for scallops. And so what I'm going to show you here is a series of maps with the distribution of some different fisheries information overlaid on this. And it's to try and explain how we got to the present lease situation, which is a good example of how fisheries information was used. So we looked at the scallop distribution, which is one of the main fisheries in our on the eastern seaboard here. We also looked at cod and cod migration in the TAG project, which was run out of the Gulf of Maine Research Institute. We looked at observer data on different pelagic fisheries like the herring and the Atlantic. We looked at study fleet information on groundfish and also different students' projects with tagging. And so that information was all combined. Oh, and then the lobster landing, which we didn't have a great deal of information on lobsters, but Bob Glenn provided us with some from Mass DMF, and the lobster distribution does seem to be moving out into the deeper waters, but we looked at the landings for the two areas. And the group then assessed that whole thing and came up with proposing that basically cut the dog. And that is how this ended up, the way it was, or at least that was the data that our working group put forward to, and then the managers took it further and discussed it. Now, for moving forward, we had a seminar by Rob Stevenson from St. Andrews Biological Station, and Rob and his group have been dealing a lot with trying to look at different scenarios for sustainable fisheries management. They looked at things like the Marine Stewardship Council, and there's all these different types of scenarios out there. And in seeing that, I thought I was involved with the Academy of Science review working group, and seeing that I think that a lot of the groups are struggling with a framework to try and move forward. And so we're doing some work and thinking about this to see if we can. I was particularly taken with Bob's presentation on how you might be able to analyze different scenarios. And so I drew this based on that, where you extend, you look at a fisheries scenario, you look at the wind farm, you compare it using the 4 pillars of sustainability, which are ecological, economic, social, and institutional. And then I also drew from Ernest Mayer's This is Ecology, and looked at, looking at it on the individual population and the community. And when Mayer was talking about this, he was talking about the species, but you could also think of it as a wind farm, as the individual turbine, a group of turbines, or a wind farm, and then the community along the eastern seaboard. And you could put it on a spatial scale. And this would be a way to start filling in data gaps and different information, and then trying to direct the study. Because it seems to me, as we've heard in this meeting already, that there are a lot of different groups working on different things, but there's a lack of a communication in some senses, and not everyone's aware of what everyone else is doing. A key example of that was just last week at the New England Fisheries Management Council. There, during the groundfish session on Wednesday morning, they were discussing the implications of window pane flounder if you go over that, either in the scallop fishery or in the groundfish fishery. And one of the ways they were going to deal with it was to put in areas where accountability measures would be put in. And those 2 areas for the different scenarios are right over the New York wind farm area, and then of course around Block Island here and in the lease area. So you have BOEM leasing these areas and basing the information on limited conflict with the fisheries, and then you go to the Fisheries Management Council and they're saying these areas are so important that if this stock is overfished, we will close these to fishing to preserve the stock. So it seems that there does seem to be a lack of communication and framework to compare it on. There's also a lot of new technology. I don't know if this is going to work or not. If I have to, do I have to hit a button? So there's all, I think that, the studies that we've seen are really great, but there's a lot of new stuff coming out. This is some of the stuff we're working on, where you have an open cod end, and we've got an algorithm now that can help us identify the different types of fish that pass through and count them. You also have new information with telemetry, some of the sound work that we've heard about. There's a lot of new technology out there which is going to allow us to really address the information that we need to kind of move forward. That's it. That's all I'm saying. I guess I'll just stand down.
Thanks, Kevin. And I'm sort of amazed to say this. We're ahead of time. It's incredible. Next up is John King.
Pretty good. Okay. I'm going to tell you about an interesting study we've been doing of the effects of electromagnetic fields on American lobster, and we've also studied little skates. And there's an international team. I'm sort of the geophysical survey field guy. Andrew Gill's an expert on EMF, and he's a biologist. Haibo, he is an electrical engineer who does models of cables and grid infrastructure. And Peter Segrays, his day job is finding Russian submarines, and then he goes out and measures EMFs with us. So we have this team, local and European, that have been engaged in this study. And there's a couple of components. The first thing we do is we go out with this device that Peter Segré invented called the SEMLA. It stands for the Swedish Electromagnetic Low Noise Apparatus. In Sweden, the SEMLA is actually a cream puff with a maraschino cherry affixed to the top of it. So the name actually is more meaningful in Sweden than here. And basically the device is shown here. It's got a magnetometer underneath here, and then it's got electrodes that measure electrical fields. It does both of these things in 3-axis measurements, X, Y, and Z, and at very low levels. And what we do is we go out and we do a survey where we drag the SEMLA sled perpendicular to the transmission cables to get measurements. And these are some measurements of the cross-sound cable between New Haven and Long Island. And you can see that once in a while we get a very interesting looking and peaked electromagnetic field. This has more to do with burial depth. When you make project burial depth, you get curves that look more like this. When you don't make project burial depth, it looks more like this. And we were surveying the field to find a good spot to study the impacts of EMFs on organisms. And once we had found areas, we could place our mesocosm enclosures, which I'll show you in a minute. We also did surveys. There's the electrical results from the cross-sound cable. And both of these electrical and magnetic field measurements produced interesting results in that the peaks were a little higher and they were significantly broader than models would predict. These fields are supposed to attenuate away from the cable a little faster than they do. So if you're looking at these things as some sort of a barrier to organisms, they're a little more formidable a barrier than would be predicted by a model of the cable. Now, to summarize the measurements we've done, we've studied 2 DC cables, the Neptune cable between New Jersey and Long Island. That's roughly double the capacity of the cross-sound cable. And then we've studied the sea-to-shore cable, which is a relatively small AC cable. And what we found is that the EMF fields associated with the DC cables tend to be higher and broader than would be predicted by models, whereas the fields associated with the sea-to-shore cable are significantly lower than predicted by models. And part of this is due to the cable design. The DC cables consist of a very large conductor and then a smaller conductor, and you need the double conductor to have a DC cable. The EMF generated by the AC cable, that's modeled as if it's a single conductor, but it actually consists of 3 twisted conductors, and both cables have shielding. And at least with the AC cable, it seems like the twisting, which is designed to attenuate and cancel out the fields, works. So we were finding values that were maybe 15% of what would be predicted by a model if you treated it as a single conductor. So any effects of AC cables are less likely to be significant relative to the AC cables. So that's maybe something to keep in mind when you're designing these cables. And the other thing that enters into it, though, is that all of this generality about what makes design criteria goes to hell if you don't make project depth, because cross-sound cable didn't make project depth. In a couple of places, the sea-to-shore cable, right as it leaves Block Island at Crescent Beach, didn't make project depth. That's where we see higher values for EMF. And fortunately, the highest values for the sea-to-shore cable don't seem to exceed a value that would have a
an effect on organisms, predicted again by models mostly. Okay, so that's our field survey results. We went out and we did these enclosure studies where we have a 4 by 5 by 3 meter enclosure that we place on top of the power transmission cable. And these things have hydrophones mounted on the corners. We went with a 6 hydrophone array, and then we put acoustic tags on organisms, and we put them in these enclosures, and the hydrophones can monitor their movements within the enclosures. So we had an enclosure on the cable. In this case, it's the cross-sound cable. And then we had one some distance off of the cable where the values were background values. Okay. Now, you can see our test subjects. This is a little skate with the acoustic tag mounted on it. This is a lobster with the acoustic tag mounted on it. The tags had to be big enough that they were reliable and there's a battery built in and you want it to last long enough, et cetera. But it didn't seem to impede the behavior of the organism. So we did a lot of preliminary testing, and in some cases there was also training. What we found is that you have to box the lobsters, let them fight so they know each other before you deploy them in the enclosure, so they don't spend all their time in the enclosure fighting each other to establish dominance. So basically you have to make them friends, or at least known enemies, before you release them into your experiment. And this is the sort of data that's generated. You're basically getting a location reading that has an accuracy of about 10 centimeters every 6 seconds. So all of these readings are these organisms moving around in the enclosures. We did them 5 at a time. So there's actually 5 organisms in there which have unique acoustic tags, and you can distinguish what they're doing. And we deployed them for 24 hours in the test enclosure on the cable, and then for 24 hours in the enclosure not on the cable. And then we compared how they behave differently between the two. So what do the data tell us? The acoustic tagging method, this hadn't been done before, so we were taking off-the-shelf stuff that was used for other things and then trying to develop a method. I think the method worked out very well, and we got very high-resolution, high-accuracy data. I've never seen a data set. Normally, each of those things is about an order of magnitude higher than what we got in this study. We're still analyzing these data sets because, as you imagine, they're pretty massive data sets. We did a lot of deployments with a lot of organisms. The lobster data to date indicate that the lobsters can detect the EMF, and they don't seem to be profoundly affected by the EMF, but they tend to engage in avoidance behavior. The little skates, on the other hand, are pretty strongly attracted to the EMF. They sort of zero right in on the cable, and they tend to hang around on top of the cable, and they spend a significant amount of time investigating the environment right around the cable. Now, the point of the study was to see if we observed effects, and yes, we observed some effects. In one case, lobsters seemed to avoid the EMFs, and in the other case, the skates seemed attracted to the EMF. But does this translate into any sort of impact at the population level in the environment? That's a much harder question to answer. I would say that based on what we've seen to date, if these organisms are interacting with a single cable, probably it doesn't translate into an impact. If, on the other hand, you get some sort of a major spider web random cable mess offshore, I don't know what the answer is. You know, like if you have to interact with a whole bunch of cables and they're not organized. Grover made the point earlier that we should probably have transmission corridors or something like that, where you're kind of organizing the grid offshore. And I would say if we're able to achieve that sort of organization, then we at least minimize the potential for impacts. So I would say good idea, Grover, so, or whoever had it first. And that would probably be the way to approach this. So, thank you.
Thanks, those were great talks. And I'm sure we have a ton of questions, but I get to take advantage of being the moderator right now. I only have about 17 questions. It won't take too long. So thank you, everybody. One of the challenges we have is assessing siting. So the first round of siting was the development of the wind energy areas. And now we're getting to the point where people are working on micro siting and where turbines will go specifically. And one of the things we're trying to avoid are sensitive habitats. And I'm sure this will come up again in the habitat section. But I was wondering from the fisheries perspective if you could weigh in on features or specific locations that you've identified that you think should be used to microsite turbines. So turbines should not be located near those features.
I'll start with that. I think it's a good question, and I had a slide that I might have shown, but there wasn't enough time. But it's interesting, I mean, from a very, maybe not from a micro, but from a macro perspective, the areas, it's kind of ironic, the areas that we found that supported the highest biodiversity in the fish and invertebrate community are the area south of Block Island and Cox's Ledge, which incidentally is where the wind energy development is cited for. So that, just because the development is cited in those areas doesn't mean there's an effect, or that an effect means an impact, but there is a pattern there that those two areas are two of the most diverse areas in Rhode Island Sound and Block Island Sound.
I don't have a comment on your comment. I have a comment on the question. I would say right now, Jeremy showed that we're on our way to beginning to establish some food web relationships between benthic habitat and fisheries. And I think it's kind of an economic decision tied to an environmental decision you're discussing. I don't think we can make those kind of distinctions at a very high level until we get a little bit further into establishing actual values for different types of habitat. No doubt we can map two built-in amphipods very easily, and it kind of looks like that's a valuable type of food source in certain areas. But until we can make a fish food map, which I don't think we can do right now, it's pretty hard to do micrositing.
Well, I guess I would say that based on what we've seen so far, that there's a couple of different elements. Obviously, the better we can map habitats, both physically and biologically, the more we understand the patterns of distribution of habitat. But I'm really a benthic ecologist, not a fishery scientist, so I'm sort of focused on that habitat on the seafloor. But my understanding is that different invertebrate and fish species use that seafloor for different reasons. It might be spawning, it might be juvenile refuge, it might be foraging. So there are a lot of dimensions and not, I don't think, one single answer. Thus far, we have definitely focused on avoiding complex hard bottom environments. That's largely because the resource agencies have at least indicated that those habitats are of high value, based on their own experience. So we'll get a little bit into that more tomorrow on habitats, but knowing that those are considered to be high value, it has been important to examine those. As we learn more, to me, the secondary question is, which we're only getting closer to understanding, is when you put a foundation on a habitat, does it alter that habitat? If so, is it a positive, is it a negative? So unfortunately, we have been citing to some degree without knowing what the consequences are. And that's true of Europe, it's true here, where it may be that certain kinds of foundations either enhance or don't particularly affect a habitat, or they may, have a greater difficulty. So Grover talked about engineering, maybe driving things initially, but fundamentally, you're not going to construct a project if the engineering is wrong. So we have to bring the engineering information together with the biological information and make sure they're in concert, that the finances and the feasibility of constructing a turbine is not always going to be exactly the same as the biological value. Sometimes they will.
Anybody else want to take a stab at that? No? Okay. Okay, my second one is, what are the key gaps in the fisheries science studies that have been done to date? And if you could be as specific as you could be, that would be great.
I'm not a fisheries scientist.
There
you go, Julia.
For
I don't
siting,
even know
for
where to begin with
siting
that.
of
I've
offshore wind
had quite
farms.
a few conversations with you, Catherine, about that, and it sounds like we don't really know. It sounds like we need to do more site-specific surveys to figure out what resources are in the area and then go from there. There are just so many questions at this point that it's hard to pinpoint.
Yeah, if you're talking about more than just the Rhode Island area, I mean, most of the information is based on the federal surveys, and those are done once a year or for the groundfish twice a year, so you don't have any kind of seasonal variation. We have very limited understanding of migration, larger scale migration up and down the coast. There's quite a difference, as I think you've seen with the Rhode Island example, between the amount of samples you have to do for a basic kind of overview of a stock assessment as compared to a before-after control impact. You have to have a much higher sampling frequency, which I think they've done and tried to undertake. So other than providing the baseline for the amount of samples that we might need to take, that's about where we're at, as I see it, that you would treat what we have as preliminary studies and then focus in on the areas and really try and get at a statistical power that could test the type of impact you think you're going to deal with.
Go ahead, Jeremy.
Okay. Well, I think Kevin was going in the right direction about understanding seasonal habitat use. One species that a lot of people are concerned about now talking about is Atlantic cod, because we seem to have a kind of resurgent cod population in southern New England, contrary to what people would expect. And so the questions that are really important there is to know whether, well, is this a kind of semi-discrete subpopulation, or are these just strays from the Georges Bank who got lost and didn't find their way back? Are they using some of these areas consistently for spawning? Are they closing their life cycle in southern New England? And so those are the types of questions that people are being asked. Whether fish species are making use of these habitats, are they staying locally, or are they just passing through in their migrations?
So I guess I would add, as not a fisheries scientist, that things that would be valuable in terms of interpreting information would be to look at some of, as Jeremy just pointed out, some of the key species. What are their requirements? So, when we look at EFH assessments, we're relying upon fairly old information on basic life cycle, habitat use, and it's very broad and very regional. So what supports the squid populations, which are obviously very important? Where are the key areas for spawning and squid mobs? What contributes to successful maintenance of a cod population or lobster resource? What are, and there some information, but we could use a lot more to be able to interpret these results.
Just a comment as a scientist. If you're going to use the BACI, we need to get a lot better with the B part. What we've done to date is really not adequate.
All right, let's open this up for questions from the audience. Eric.
There are a number of important forest species, both for predatory fish and as well as marine mammals, that are more pelagic and thereby would be underrepresented by a trawl survey. So how do you account for their abundance in the areas, particularly areas where construction would occur that might cause an avoidance reaction and thereby causing a behavioral change to those predatory fish or marine mammals as a consequence?
Can you repeat the question too, please?
All right. So I believe the question, Eric, was relating to forage species, very active species that are generally up in the water column and are not going to be effectively sampled with trawl surveys, bottom trawl surveys in particular. How do we assess them? I think I would add to that the construction activity and the operation of wind turbines involves creating and placing structure in the marine environment. And it's very localized. And what we do know about those very active fish is that some of them are drawn to structure. Other fish are drawn to the fish that are drawn to the structure. And it's very challenging to do those studies. However, there is a long legacy of studying oil platforms and their impact on fish communities, not so much in New England because we don't have those structures here, but we could adopt some of those approaches. They're much more time and labor intensive, and ideally, personally, I think telemetry and tagging would be a really cost-effective way to begin to look at that kind of a problem.
Go ahead, Beth.
I have a question for Jeremy. On your ventless trap survey, do you have any information available that shows the size, sex, disposition, whether it was egg bearing? Do you have that information available?
Yes, good question. Thanks for that. Yes. And I didn't present that because of the time constraints here, but yes, we do have that information, and it is in our final report. And I'll make that final report more easily available to you, so you can find those data.
I have a follow-up. Have you considered doing a settlement survey?
Can you just repeat the question real quick?
Okay, sorry. Well, the first question was whether there are additional data available from the ventless trap survey, and there are lots of data, not just on lobsters, but on crabs and other fish, and all those data are in our final report to BOEM, which is publicly available. So if anyone needs help finding that, we can point you to it. The second question was whether we've considered a settlement survey, and we have considered that, but at this point, we don't really have the resources to initiate that. But I think that is a good idea because there's a lot of interest in knowing whether there's self-reproduction in offshore lobsters or whether those areas are dependent on settlement from other areas.
Go ahead.
This question is for Julia. It was clear by your research that New York site had squid milling. That led you to expanding the study for all species in the geographic area of the 3 lease areas. And it wasn't clear to me what species these were historical landings, and I understand these are sort of like fact. These are the fish that were found. What fish were found around the lease area?
Which lease area?
Well, the three lease areas, the Cox Ledge area, and then there were two, I guess, there are two sites southeast of that, they're all included. What species were, just, because I couldn't tell by the presentation.
Yeah, there's a lot going on in that area. We saw a lot of the multi-species fish, so the groundfish. We saw a lot of monkfish. And I think you said that's also the same area that you had really high biodiversity in your study as well. But this is all going to be going online so you can dig in deeper in a few months. It was a huge swath of ocean that I was looking at, so it's kind of difficult for me to remember every single spot individually. But we broke it down by which port it's going into, what species, or which fishery management plan it was managed under, so you can look at different species grouping and go into more detail. And I also have it at a closer resolution specifically for the areas off of Rhode Island and Massachusetts.
Back.
Thank you. So this question is for the whole panel, and relates to kind of what we need to do going forward. So a lot of the research surrounding fisheries and in general for offshore wind has been fairly piecemeal. It's a new venture and we kind of put it together as we go along. So I'm curious on your recommendations for standardizing both over time and across space, because we really want to have the power to detect changes. What we need. Also related to the kind of the Leblanc, so some of the work that Jeremy presented is over 5 years old now. Have this being honest, I know. So at what distance in time do we still consider a baseline characterization, and at what time do we need to revamp that? So kind of a two-part question, but for the panel.
Okay, the question is for the whole panel, and it's the research to date has been piecemeal. So how do we go ahead and standardize across time and space? And the second part is, how long is a baseline study good for?
Well, I tried to, thank you for the question there, and I tried to put forward a possible framework. I think that, that this kind of study, you're going to have to look at the environment, because the environment's changing. It's going to have to be an ecosystem approach, but you're also, it's going to have to be a social approach as well. And I think that, the study you guys did a few years ago presented a lot of options with that. But I think that it's time to pull it into a framework, decide on what kind of scales that you want to look at. We've already mentioned that seasonal is important, and that data seems to be pretty lacking right now. So probably we're going to want to start looking at it in that fashion as well. So that's what seems to be really called for right now, is some kind of stripped down like leadership and a time frame, a framework, and really start pulling all these together and moving forward in a more focused agenda.
Maybe I'll add to that. Yeah, I mean, add a few comments about the standardization. I think that certainly with ventless trap surveys, we've made efforts to standardize the method so that the data will be available. It's harder with trawling because each boat is a little different and there are differences in catchability. I wanted to come back to John's question about the before and doing better in the before. As you can see, it's really challenging because when we started the SAMP, we didn't really know where the developments were going. So we were trying to cover the whole area of Rhode Island Sound, Block Island Sound, guessing, making our best guess. Even with the lease areas, you don't know about the timing of them. There are other things that are involved, obviously, about the economics of that. And even when the area is leased, you don't know where the development's going. So you're kind of guessing where your impact site is and trying to cover a lot of ground before. And I know that with the habitat studies, we've been jumping around trying to second guess all the time. So that really is a challenge. I'll just say a little bit about microsighting and with the lobsters, with the South Fork area. I mean, coincidentally, that's the area with the lowest lobster abundance in our study area. So you might say, well, that's a bit serendipitous that, if we were to recommend the area that would be least impacted, that would be the South Fork area. Of course, it wasn't decided that way. It was decided because it was closest to Long Island. But I think the data we do collect can be useful in micrositing.
Quick comment. The answers to those questions, I think, kind of cry out for some sort of a best practices exercise at this point. And one thing that I don't think is feasible is that at a meeting a couple of weeks ago, one of our Belgian colleagues suggested that you come up with your best practices and a single group do all the work. And I think he hadn't looked at a map from the Canadian border down to the Carolinas and hadn't scaled it relative to Belgium. So I think basically that's sort of a non-starter, but if we all agreed on methodology and protocols, that would be a good start.
So you're not going to do those cage studies all over the Eastern Seaboard?
No.
Oh. Well, following up on that just a little bit, I was wondering if you could also address like the regional question. What is the region that regional studies should be done in? Are we talking about Canada to North Carolina? Are we talking about New York to Nantucket? Are we talking about Rhode Island and Mass?
Well, I mean, for the region, I think the region is from, when I think the region of it is from Florida to Labrador. And that's based on particularly some of the tagging work done in the Minas Basin, where they tagged 13,000 shad, and they got shad back from every river from Florida to Labrador. So all those fish were moving along the continental shelf and schooling in there to feed in the summer and then moving back. And if the shad are doing it, then the river herring are doing it. And so are the striped bass and other animals following it. And so and how are they doing it? Are they doing it from using electromagnetism? So, there was one study I think on eels, right, where it slowed down. They were slowed down by the migration because of electromagnetism. Depends on how many cables you have. But I think that you need to think on the micro scale as far as the turbine, but I think you have to think about the whole seaboard as well. And certainly, at least some of our fisheries are starting to move that way. And if the fisheries are moving that way, they should move that way as well, I believe.
Drew,
I guess I would add that maybe part of what John's referring to is that we know that we have a shifting baseline, that with acidification and temperature change, all these communities are altering on a pretty fast time scale. So that regional picture is almost mandatory. And secondly, I guess I'd make a pitch for preserving the old and looking forward, so that we have data collecting efforts that have gone on for a long time. We need to support those, perhaps expand them a bit. I'm referring here to both the stock assessments and NEMAP. But then we need to look at new technologies, look at remote sensing, telemetry, other things that could very rapidly expand our understanding on a big scale. And we're going to have to combine those two.
All right, thank you, panel. Please join me in thanking the panel.
All right, folks, we're ready to start the final session of today. So the final session today is the final session today is what's keeping you from getting a drink. Right? So the reception will follow this, and the final session today is fisheries. And really, so far today, we've heard about quite a bit of science that's gone on. We've heard some stakeholder perspectives, and which I find really important, the perspectives of getting their questions answered, the perspective of cooperation, the perspective of group participation, listening to other opinions. So that's all real important. But right now we're going to have the fisheries section, and we have 5 people, 2 fishermen, Rick Bellavance from the Charter Boat Association, and Lanny Dellinger. He is the chair of the Fishermen's Advisory Board for CRMC, but he's a lobsterman from the Lobstermen's Association. We have Elizabeth Marchetti. She was the fisheries liaison for the Block Island Project. She is the fisheries liaison for the Block Island Project. We have Sue Tuxbury from NOAA Fisheries, who will talk about really fish issues. She could have been with the last panel. She's also going to be on the habitat panel, so she has a breadth of experience. And then finally, we have Ed Leblanc from the Coast Guard. And you might say, what's he doing here with fisheries? But what's the Coast Guard responsible for? Safety. Safety for fisheries, safety for fishermen, safety for everyone. So he's definitely appropriate here. So each of them are going to give a short introduction to their perceptions for what they've learned in the process. So I should say that for the wind power project, for the Block Island project, I've been involved in this since 2007. So in the initial planning stages for really the fisheries aspects of the Ocean Special Area Management Plan. Worked with lots of you. I've worked with this group of people a lot. And they always bring a real professional attitude to the meetings that we've been in and to the planning. We don't always agree. That's okay. This is America. We don't have to. But we have to resolve our problems together. And hopefully, as time is passing, our problems are minimizing. But we also heard earlier today about how much science has gone on, but how much more science we need. So tomorrow we'll hear about a bunch of other scientific aspects. But hopefully, at the end of the whole 2-day program, we will have a better handle on the science that needs to be done, and we will all know what each other has been doing in the scientific realm. But with that, let's move to our fisheries panel. Rick?
Thank you, and welcome to the highly coveted 3:30 p.m. panel discussion. Recognizing that I'm standing between you guys and happy hour, I'll be as brief as I possibly can. My name is Rick Bellavance. I run priority fishing charters in Point Judith, Rhode Island. It's a pretty cool job. I get to bring people fishing. It's cool when they're biting, not so cool when they're not biting. But in addition to that, I'm also a fisheries manager. I represent the great state of Rhode Island on the New England Fishery Management Council. So we get briefed pretty regularly. Brian Hooker comes to most of the New England Fishery Management Council meetings. We also have a habitat committee that engages now pretty fully in offshore development of wind farm projects. And so we're informed on the fisheries management level as well. And probably most germane to this panel discussion was my role as Deepwater Wind's first fisheries liaison during the permitting process, not the construction process like Elizabeth will speak to. During that process, I was responsible for trying to get the fishing community and the wind farm developers to sit around the table and hash out some of the differences, the questions, and the concerns that would revolve around putting this first ever wind farm project in our backyard. It was a super enlightening role for me to have. I was able to, I think anyway, get to a lot of solutions that resulted in the end project that we've all heard about is a successful wind farm off of Block Island that most of the fishing community is pretty satisfied with how it came out. It wasn't always rosy and smooth. I think Chris Brown hit on quite a bit of the points that, that started out with a little bit of a rocky road, but as time went on and we built trust within each other, I think some really good solutions and really good outcomes came from the project. I think that one of the things that we did do during that permitting process, was to bring the fishermen to the table with the wind farm developer one-on-one, absent the government process, the government permitting process. I think that government process is very important, but there's also a role for that business-to-business discussion to work to develop solutions to issues. And I think that was a trust-building exercise. I think it was part of the reason why the project was so successful from the fishermen's perspective. One other thing that I just want to briefly talk about was mitigation. It's always on people's minds when you start to think about competing interests on the water. Chris mentioned some of the mitigation on the commercial side. I wanted to mention one thing that we were able to accomplish on the recreational charter side. And instead of just writing out a check to a fisherman saying, hey, sorry we displaced you, here's some money, we thought it would be smarter and a better investment to develop a marketing campaign that would help promote charter fishing into the future. So I think innovative, forward-thinking ideas like that should always have a place at the table. You can get more long-term benefits out of a project, a marketing campaign, than you would just a check where you'd go buy a pickup truck and then 10 years later you need a new pickup truck. So I thought that was a pretty neat part of what came out of that process. And the last point that I wanted to make before I move along here was how each project is different. I think depending on where you put them and what type of project is going to be developed, you're going to have the same fishermen at the table. Maybe you'll have a group of different fishermen that you've never met before. Maybe you'll have a combination of the two. Different fisheries will be impacted. Sometimes they'll be the same fishermen that are impacted. But it's important to recognize that strategies for permitting, planning, and developing projects are going to be different for every spot. So that's kind of what I had. Next.
Hi, Landy Dellinger, lobsterman from Newport. I think I've been involved in this probably as long as Dave has. And kind of a bummer going third, because I think Chris and Rick has stole most of my ideas as to what to talk about. But I think one key thing that everybody's touched on from the fisherman community so far is it definitely wasn't all cake and ice cream going through this process. I think early on it was shock for the industry to actually realize that this was reality, this was going to happen. I mean, how dare they put this in my backyard, and I'm going to have to drive out into the ocean now and see something out in the ocean that I haven't ever had to deal with before. But I think once you come to that realization, the industry decided that we needed to be engaged and work through the process, and because we didn't want to be collateral damage in this thing. So that's I think that was the driving factor. And working with the CRMC early on, like again, it was building that trust factor. And once that trust started to be realized, there was a lot of things that came out of it that were very beneficial to the fishing industry. Federal consistency, enforceable policies, facilitated talks directly with the developer. gave the fishing industry some legal standings, which we had nothing. We don't own the ocean, we're just another user group. So the FAB's role in this whole process ended up, being a lot more than you would even imagine. From micro-siting, we were able to work with Deepwater, Aileen and her staff, if you move a turbine just a little ways, it can do much less harm to an industry or allow the two industries to coincide and live together. We had input into a lot of the survey work, things like when they're out there, dragging their side scan sonars and whatnot. If there's just a little bit of communication there, a lot of conflict can be avoided, gear conflicts, things of that nature. Even to the cable landing, there was a whole host of meetings. I couldn't tell you how many times I got to meet with the folks at Deepwater, working with the CRMC through the whole process. It was so important to be able to do that and mitigate a lot of the problems before they arose, which allowed both industries to go ahead and go about their business. So I think there's a lot to be learned. Everybody can learn a lot from this. The state agencies that are involved can learn from what they did here in Rhode Island, what the CRMC did when they did the ocean SAMP. The fishing industry can learn a lot. Get engaged early, stay engaged to the end, because like Dave said, we don't always agree. There's a lot of headbutting that goes on, but overall it was a good process and you got a good outcome because of it. It's the only reason I think that project is up and running today was because of the process that took place over 10 years' time. And the other thing, a lot of the developers, I believe, can learn a lot from the way Deepwater handled this themselves. They didn't come into the room like a 300-pound gorilla. They did this small project to begin with. Even with the South Fork project is a smaller project in the grand scheme of things. The problem that I see is BOEM gave out these leases for all across the ocean. Now, I'm an Area 2 lobster fisherman. That means I'm bound to a certain area within the ocean where I can fish. And if we're going to have projects going on from Cape Cod or Martha's Vineyard all the way over to Montauk, well, that's where I'm allowed to fish. I'm not allowed to go anywhere else because of permits. So with working with developers, if they can work with the industry and not come in like the 300-pound gorilla, and we're going to put 200 turbines and we're going to take out this whole piece of ocean all at once, that displaces everybody, because the fishermen that are already working in that area are going to be pushed to have to go fish in another area, and there's somebody already fishing there. So if you look at it on the concept that what we have to work with out there is a pizza, and if some developer comes in, he says, I'm taking half right now, I'm taking that off the table, and the remaining industry has to try to eat what's on the other half, well, guess what? Everybody goes home hungry, and there's going to be consequences for the fishing industry. People aren't going to be able to survive these type of things. So that being said, I think I've covered about everything that I can cover. Thank you.
Thank you, Jennifer, for having me. It's been a great day, extremely informative and educational. One of the earlier panelists mentioned credibility, so I'm glad he brought that up because it kind of sets up me pretty well. I thought I'd give you a quick background of who I am and why I'm here. So I'm from Long Island, New York. I graduated URI with a marine biology Bachelor of Science, and immediately after graduating school, I started working for the Lobster Restoration Program with the Ocean Technology Foundation, and that was in response to the North Cape oil spill. I worked through the program for its entirety of 5 years before accepting my federal contract position as a NOAA port agent in Point Judith, where I assisted fishermen daily and regularly with questions and concerns, as long as conducted port-side biosampling. From there, I was offered a federal contract position with NOAA's Cooperative Research Branch, and that's what I'm currently doing as a field scientist. And we work with electronic reporting with the fishermen and technical assistance, along as at-sea biosampling. So that leads to here. In May 2015, I accepted the position as the fishery liaison for Block Island Wind Farm. I was selected from a pool of candidates, which was reviewed by National Grid, Deepwater Wind, CRMC, and the Fishery Advisory Board. So as the fishery liaison, what did I do? I created a listserv of my contacts, which was an easy and transparent way of getting notifications and updates out, which consisted of academia, government, commercial fishermen, stakeholders, et cetera. I made port visits and dealer visits to get information out there. I had Block Island and Point Judith meetings about construction schedule and updates, and assisted and facilitated communications between Deepwater Wind, CRMC, National Grid, and the commercial fishing industry. I also conducted gear cruises to ensure that there was no gear conflicts within the work area, and if there were, I had to approach the fishermen to tell them to move their gear, which wasn't so much fun. So that's basically it in a nutshell. Looking back, the two main obstacles I can think of being in the fishery liaison position was there was no formal introduction of my position. So I think there was a lot of misconception, misunderstanding, bitter reaction from certain members of industry of who I was. They knew me in my other capacities, but they didn't really know what I was doing and who I was with. And that the CRMC OSAMP fishery liaison position is an independent contract position, so that, the guys didn't really understand that from the beginning. Also, I think the beginning of construction, it was the notifications I was receiving from the construction company wasn't as detailed as I would have liked, or I didn't receive the information in a timely manner where I could send out the information to the guys so they could make their business plans. So that wasn't too fun. But by 2016 and the second year construction, both issues seem to progress positively. So I'm still accessible for fisheries questions, and feel free to contact me anytime. It's rifisheryliaison@gmail.com. Thanks.
Hello, I'm Sue Tuxbury with NOAA Fisheries Service. I work in the Habitat Conservation Division in the Greater Atlantic Regional Fisheries Office. I was involved with the Rhode Island Ocean SAMP from the beginning, as far as a stakeholder and providing technical assistance. I did the essential fish habitat consultation for the Block Island project. I did get to see firsthand. I went to a number of the public meetings for the Ocean SAMP from the beginning, so it was quite a transformation to see, how I guess the level of public comment, and it was clear that they had done a lot of their work coordinating with industry, which was terrific. So I think that absolutely helped with the Block Island project, with the EFH consultation and as well as with the fishing industry. I think the offshore areas are a bit more of a challenge. The states, Massachusetts and Rhode Island in particular, have done great with continuing to engage the fishing industry with the working group and the FAB, and we're seeing a lot of, because there's no state boundaries for fishing, we're seeing a lot of concerns from fishermen outside the state as far as the state-by-state process with the offshore wind farms. So I'll be working on the EFH consultation, which is for Maine through Virginia, and our agency will also be commenting related to fisheries issues, access, displacement. We'll be commenting through the NEPA process on those. I see kind of our role is having to look at, that we should be looking at these cumulative impacts and looking at it from a Northeast Shelf view versus state by state. And so we're in the process now, since these projects seem to be more and more seem to be coming down the pipe. We coordinate internally. I coordinate with our sustainable fisheries group quite a bit, and we're kind of formalizing a renewable offshore wind team to get contacts from all the divisions in our region, as well as our science center. And I have been working closely with our Science Center, try and get a sense of any other data that, particularly with the New York one coming up, the call for information of data that we may have that may be useful for the process. So that's also part of what we do. And you know, we're looking, you know, another thing we have to think about for cumulative impacts is not just, you know, looking at all the offshore wind, but also when you look at fisheries, there's a lot of management. There's closed areas, gear restricted areas, habitat management areas. And I think it's important to look at, you know, include that in the cumulative analysis as far as the impacts to the industry. And not just looking at the different wind farm projects, but what else is going on the offshore area. So, and with, I did want to just quickly touch on, there was a comment on anecdotal information. I can say that for the EFH regs do allow for anecdotal information to be incorporated into that analysis. So I would certainly encourage the developers to accumulate some of that information for the analysis, because it can also help to determine potential data gaps of where we should be looking. So that would be, so that's all I have.
Good afternoon. Thank you, Dave. I'm acutely aware that I am the last speaker on the last panel before we get to food and drink. So, Jen McCann, thank you very much for inviting me to a science forum to speak about a topic that is very much an art, even here in the 21st century, with a good dose of science. My name's Ed Leblanc. I'm with the U.S. Coast Guard. My role is to conduct, to analyze navigation safety risk assessments for wind farms in this area. So I was filling that role for the Cape Wind farm and for the Block Island wind farm, and we'll do the same for future wind farms that'll be developed, such as South Fork and the other wind farms south of Martha's Vineyard. So the Coast Guard's interest, you've heard the word used many times today, balance, and our interest is to facilitate a balanced use of the ocean, be it industry or commercial vessel industry or fishing or aquaculture, as you work frequently, Dave. Our interest through navigation safety is to facilitate ocean uses by all of the potential ocean users. So we do this by engaging with current and potential ocean users. We assess new ocean uses for potential impacts to navigation safety, as we do with wind farms. And then we apply a wide spectrum of mitigation measures or potential mitigation measures that we might bring to bear to balance navigation risk where perhaps they are not adequately balanced. So you can imagine those mitigations range from anywhere from perhaps a simple chart notation on nautical charts to perhaps closing the area to navigation, which is an extreme measure. We haven't done it. I don't see us ever doing that, to be honest with you. But that's the nature of the spectrum of mitigations. So with the Block Island wind farm, we asked the proponent through the lead federal agency, because the Coast Guard itself does not have approval or disapproval authority for any of these projects. We simply act as the federal government's navigation safety expert, and we advise the lead federal agency on the potential impacts that might be expected from the proposed wind farm. So in the case of the Block Island wind farm, the lead federal agency was the Army Corps of Engineers, because this wind farm, the Block Island wind farm, is in state waters, not in federal waters. So we serve the Army Corps of Engineers as their navigation safety experts. They outsource that function, essentially, to the Coast Guard. So we asked the proponent, Deepwater Wind, to provide a navigation safety risk assessment, which they did. We analyzed that. We recommended to the Corps that certain conditions be included in the permit issued by the Corps, and those conditions, as you might imagine, are things like the lighting and marking of the towers, including some sort of ability of mariners to grasp on to the towers if they are in distress, those kinds of things. Monitoring of the wind farm, conditions to notify the Coast Guard if there are any issues and so forth. And then the Coast Guard monitors compliance with those conditions. We also look at any interference that we think the towers themselves may cause with vessel electronics, VHF radio in particular, and radar. We take a look at those issues to see how they might be impacted. So far, there have been no impacts or minimal impacts that we are aware of, as was modeled. So since the construction of the Block Island Wind Farm, we have some anecdotal information that tells us that there's an uptick in recreational fishing, that there's an uptick in sightseeing vessel excursions, and that commercial vessel traffic patterns have not changed, and we expected to see all of those. And I heard today from the previous commercial fishermen and from you folks here that apparently commercial fishing is still quite active there in that area, which is good to see. So going forward, for the South Fork Wind Farm, which we're working with Deepwater Wind on that now, and for any other wind farms that may be developed, it'll be the same process. We will ask the lead federal agency. In those cases, it'll be BOEM. We'll ask BOEM to ask the proponents for a navigation safety risk assessment, and the Coast Guard. We don't prescribe how those risk assessments are conducted. We do have guidance, but the proponent can essentially select any methodology they wish. It can be quantitative analysis or qualitative analysis or a mix, and most of these studies we're dealing with navigation safety. Qualitative normally doesn't answer the mail on that issue, so it's mostly, if not entirely, a quantitative risk assessment. And, excuse me, did I mix that up? I got a qualitative risk assessment is what we want. And so that's what we'll do going forward. Thank you.
Thank you. Now, as moderator, I get to ask the first question, and then we'll open it up to the audience. But you've all, given a good background, and a few of you have talked about different issues you see going forward. But if we think about, say, the next three or 4 years, in southern New England, there will likely be 3 projects running at the same time, or there may well be 3 projects running at the same time. So what I would like each panelist to do is think about and then say how your work life would change with 3 projects running at the same time. And what issues do you see for everyone with 3 projects running at the same time? And anybody that wants to go first, please do.
Again, I think the devils are going to be in the details. I mean, that's going to be a hard pill to swallow, I think, knowing that they're all going to be in Area 2 where I fish. So it's going to be tough. It's going to take direct relations with the developer. I would hope that the Fisheries Advisory Board that was established in Rhode Island actually gets established wherever there's going to be a project. I mean, it's so important for the industry to have that relationship, both with the governing bodies and the developer. It's the only way we can coexist, because if without that, I can just see the industry being run over. We will become collateral damage. If it's done the right way, we should be able to coexist. But if it's not, it's not going to be a good outcome for the members of the fishing industry. If your permits allow you to go somewhere else, you'll be able to survive this. But if you're locked into, like myself, from the beach out to 40 miles or so, it's going to be a tough pill to swallow for sure.
So Dave, I would say, to answer your question, my answer would be captured in basically 2 words: cumulative impacts. And that's what we'd be interested in if there were 3 projects going on simultaneously. And in this area, as you saw earlier today from some of the graphics, the lease areas are adjacent to one another. So if there were 3 projects going on at the same time, from a navigation and safety perspective, our interest is to look at the predominant vessel traffic patterns, be they commercial traffic or recreational traffic, and to ask the question, how would a mariner get from point A to point B through those wind farms? You know, and so the tower pattern of one wind farm, if it's symmetrical and you know they're a half to a 3/4 of a mile apart, that's one thing. But if the next wind farm is a sort of a haphazard, asymmetrical pattern there, you know, that causes us great concern, obviously, as it would cause any mariner. And then I think it was Lanny who mentioned, you know, displacement. And so if we found that the layout would not only create navigation risks, but might displace an entire fishing segment, we'd take a very dim view on that as well. Not because of the fishery so much, but because the navigation was so severely impacted that the fishing community felt that they couldn't fish there anymore. If they couldn't fish there anymore for some other reason unrelated to navigation safety, we don't have a dog in that fight. But if it was navigation safety related, yeah, we'd be very concerned about that. So that cumulative impact, you know, across the breadth of those areas would be very much a concern to us.
Yeah, I'd just like to add that there would be, you'd have temporary displacement while the construction's going on, and depending on the user group, the gear type, in a lot of cases, you really need to work with the mobile gear sector too. I mean, you know, I'm a lobster fisherman. A lot of my friends are with the mobile gear sector, and if they're not allowed to work with the developer or have, you know, face-to-face conversations, they can mitigate a lot of those the permanent impacts. During construction, we even saw it with the little project at Block Island. You know, people get displaced, and one thing comes to mind is I was asked to cover for a friend of mine doing a research project involving the wind farm. And actually, Elizabeth plays a role in this story also. But I was asked to go over and cover because he had some boat issues with his boat. So the day that I went over there to hold the research gear with the researchers on board, lucky me, I get to go there after something happened with the barges and the tugs that towed the gear around. So I had to try to find this needle in a haystack. You know, first time being over there. And thankfully, I got there right in the midst of this happening, and I was able to, which was another good thing that came out of the Fisheries Advisory Board, is getting a fisheries liaison. So I was able to get on the phone and say, stop, you got to stop what they're doing, because what we had was tugboats and barges out there milling around, dropping their cables to the bottom, just kind of laying there. Well, while they're laying there and that cable's dragging, the gear's going with it. You know, the commercial gear was out of the area. They had been told they couldn't fish it. This was Deepwater's own survey gear. But thankfully, I was able to get on the phone and put an end to it. I mean, we got the problem resolved, and I got the gear back, and all was well. But it's just a good example of you know, how things can go awry real quick. So communication is so important. Thank you.
So I guess the short answer is I have no idea, honestly, what it's going to be like. But I can say that with my particular fishery anyway, when we need to go to that area, we need to go to that area for a reason. We're targeting a specific fish, or we're looking for something in particular, and if we lose access to it during a construction of a project, then that's going to modify my business for the season, you know, multiple years, however that works out. So I'd have to think that through a little bit. You know, how do you convince one of your clients that what they wanted to go catch, they're not catching, they're catching something different, and this is a better idea. So I have to figure that out a little bit. And then in my other role as a fisheries manager, I wonder, as the council deliberates and offers input into the different projects that are going to be proposed, what that'll do to staff time and at the council, and how that staff time will be taken away from other management actions that we find important as well. So those would be some critical things that I would think about.
Yeah, I think that's a good point to raise as far as the staffing and resources. I would imagine I'm going to be quite busy with this for quite some time. But I would also go back to, cumulative impacts. If you're looking at 3 projects, particularly in the close proximity of these projects undergoing construction all at the same time, we would certainly expect some cumulative impacts as a result of that, and that would certainly need to be evaluated through the NEPA process. That would, at least during construction, could potentially, cause an even wider area of displacement and have greater impacts there. So I think cumulative impacts is important, but yeah, and staffing and resources, I can say, even in our office, my job, even though I don't only do wind, but I mostly do wind now because it's being so busy. And we're trying to pull some more folks from Stano Fisheries and some Science Center people, and it's more time and resources for sure.
I guess from the fishery liaison perspective, it would be a full-time job for sure. You better have a good phone because the phone's going to be ringing off the hook with 3 projects going on, and you're probably going to get punched left and right to start off. And then, as Lanny mentioned before, communication is key. And I know we hear it all the time in this state, transparency, and transparency is so important, especially in all avenues with the construction company, the developer, the fishery liaison, the fishermen. Communication is really the key to everything run smooth, I think.
Great, well, thank you all. Now, we'd like some questions from the audience, but and any of you that know me know that I can't hear worth a darn. So please even stand up when you ask your question and ask it louder than you think you should. Okay, Rich.
Thanks, Dave. Rich Hittinger with the Rhode Island Saltwater Anglers. Dave, as you know, we represent over 5,000 recreational anglers in southern New England, and we've been involved in the process right from the beginning with the Ocean SAMP. You came out, met with us many years ago. And I think my question is primarily to Ed, and it's kind of a loaded question in that one of our key concerns was that we have access up to the structures for the purpose of rod and reel fishing. And this would be a key issue for any hook and line fishery anywhere along the East Coast if turbines are built in an area where there is fishing. Now, of course, Cox's Ledge is the next project likely to be built, the South Fork project, and that project is on Cox's Ledge. It will be in an area where there is hook and line fishing, and I wanted to ask if there is any issue that the Coast Guard sees with that project that would require any type of a buffer zone that would be different than what we see at our Block Island project, which is no buffer zone.
No. Thank you for that question, because that's a question that frequently comes up, and I think that my answer has been consistent regardless of the forum that it comes up in, and it's every place I go in New England it comes up. There is no exclusion zone or buffer zone around the 5 wind towers at Block Island, and there will not be in the foreseeable future for sure. From what I know of the South Fork proposal, which is still being developed, there are no plans for any sort of buffer zone around any of those towers. And from what I know of the other projects that are being developed, we have no plans for buffer zones around those towers, with the exception of during construction. And we have a 500-yard buffer zone around each tower site. And even for the Block Island Wind Farm, those zones were only enforced or only effective at the particular tower that was being worked. So the other towers, if they weren't being worked, actively worked, there was no buffer zone, and there won't be a buffer zone at South Fork either.
So before the next question, I've been to many meetings with Ed for over the last 10 years. He has been consistent in his message and as clear as he just was every single time. And yet every meeting I go to, that question still comes up. So, great. So,
Dave, just to add to that, one of the reasons is because there was someone, a colleague of mine was at a meeting recently in Massachusetts put on by the developer for a Swedish firm that has leased areas, and they got an answer from their Coast Guard representative up there that he thought there would be exclusion zones, but he wasn't sure. And so that's why I emphasize it. I'm sorry.
So the question's great. What I think we should do is appreciate Ed's clarity and consistency. So the next two questions, one will be from Bill and followed by Catherine.
Thank you, Dave. My name is Bill McElroy. I'm the former chairman of the Fisheries Advisory Board. And the question is probably a relatively rhetorical question at this point, but with the idea of 3 projects. We've heard earlier that the reason why the fishing industry was so supportive of this first project is because we had trust. And that trust was built because of yourself and because of A.V. Kenny. Both of you worked wonderfully with the industry to try to build that sense of trust. How are we going to find 2 more people like you to do that next year?
That's a good question that I have no answer for. So. Catherine.
My question isn't too dissimilar from that. So communication has been talked about many times today, and we're talking about New York potential areas. We're talking about the Rhode Island Mass wind energy area, 2 wind energy areas that are currently leased in Massachusetts, and 2 more that are going to be auctioned off within a year. So, we're talking about more than one company, and so I was wondering if you could reflect on what an efficient communication strategy might be for the region to be able to enable that outreach and not kill fishermen. I mean, you can't go to 55 meetings a month, right? So could you reflect on that for me?
Well, I think over in Europe, or where the big farms are now, they have a fishing representative, and I believe that representative. It's hard to say. I'm not an expert on it, but basically you'd have the representative, and then you'd have the liaisons within the community. So there'd be one representative and multiple fishery liaisons to go to that representative. And I believe that's how they do it overseas. And I would think that aids and assists in a larger scale project.
Yeah, I'd just like to reiterate what I had said earlier. I think that's where you need to have a fisheries advisory board for each particular development. I mean, I think it's very important. And the other part is funding. You need to have. I can't tell you what a financial burden is for a fisherman. I mean, I thought that was the greatest thing when that woman from NOAA got to call in today for this meeting. If I had $5 for every meeting I've been to in the last 10 years, I probably wouldn't have to fish anymore. But if I could just make a call in from my boat, sure would be very helpful. But yeah, we need to find a way for fishermen to be able to stay engaged, because that was the hardest part, I think, for all of us. I mean, if it wasn't for Rick and a couple other guys really putting the time into this process, which went on for, like Dave said, I think it's 10 years, and here we are again, the only good week all week to go fishing, and here we are at another meeting. So it's really important to figure out a way how we keep the industry engaged in all of this stuff. And you know, again, like I said, the fab, I think that's so important for every project that's coming up. You know, they weighed in on research projects, helping to design research projects. I mean, some of the research projects when they first came out for this particular project were, you know, from an industry perspective, was laughable, you know. But after being able to work with the developer, work with the researchers, and they could understand, we learned to understand one another, their needs, our needs. We're able to make it work and be successful. But if you don't have that, you're doomed for failure. I mean, the industry is going to become collateral damage.
So each project will be different. A different strategy would probably have to be employed by the individual developers for each project, depending on the size of the project, depending on the location of the project. But I do think it's born on the developer to put boots on the ground, to understand the community, understand who is going to be impacted, who are the leaders in that community that the fishermen trust, that they want to listen to. I am pretty supportive, very supportive of the project that we did here on Block Island, and that can be held up as an example. It can give the fishermen some comfort that there is a possibility that they could be listened to if they participate. But it is a lot of responsibility for the developer to do some of that legwork and to figure out who these individuals are that can do the best job.
Yeah, I just wanted to say one more thing on that. I wasn't here for Chris's presentation, so I don't know if he even got into the muddiness of when we first started. But to build that trust, you need to be able to go to the meetings and not wake up in the morning and read in the paper about another meeting that was going on. So there was a lot of stuff that all really is important that need to come together to get that trust relationship built.
The projects that are going to go on these lease sites, are they going to always involve two companies, kind of like the one doing the Winform and then the other, and then like the way National Grid brought it to shore here? So is there always going to be another company involved bringing the power?
So the question is, will there be two companies involved in all of the projects? One for developing the project and running the turbines, and the other one for shoreside delivery of power. I don't know the answer to that, and maybe somebody else here does. So the response was, sometimes. More questions. Anna.
Question for the panel. So, again, thinking forward, in your experiences, you've all been involved in different ways of development from different sides of it. In terms of thinking about, again, standardizing across developers and across areas, what do you think are priorities for requiring developers to take a lead in, or requiring in terms of research or outreach? Obviously, you talked a lot about liaisons, which is a priority, but I'm thinking about other priorities as well. What do you think really should be required rather than just recommended? So something that has to.
Fishermen's engagement, fishermen's voices, fishermen's concerns, and involvement from day one, which is said multiple times today as well.
So for you, does that look like a liaison representative or something else?
I'm sorry, say that again?
So for you, does that look like a person, developers being required to?
I would say everybody that's concerned about it. So as the whole fleet should be concerned about it, and they should be as active as Joe Schmo. So I think sometimes we see the same fishermen step up to the plate over and over again to take the lead on things, and something as big as offshore energy and wind farms is everybody's concerns that makes their livelihood on the water, and they just shouldn't sit back anymore. So I mean, maybe that's more directed towards the fishing industry, but the developer should definitely take notice that they need their involvement for things to move forward as smoothly as possible.
Yeah, again, I said that's the role. I think that's where the role of the Fisheries Advisory Board comes in to be so important, because like Rick has said, every development is going to be different. It's going to be different users, different user groups, depending where they're placed. And that's where the makeup of the Fisheries Advisory Board, which is what they did here in Rhode Island, is you get the people who fish there, the representatives from the industry that know the bottom, know the grounds, whether it's research or if they're out there, doing their side scan, sonar, or doing any of the planning, to get the fishing industry involved. And that's a hard part to do. I mean, for this process, I mean, there was years of meetings that went on, well-published meetings, and there was the same, 8, 10, 12 guys that would go every week. And there was the guys who just would, wanted to bury their head in the sand, this isn't going to happen type of thing. So I think it's important to engage the people who fish the area, know the area intimately, and get their input, on all aspects of it, whether it's research or it's how they're going to run the cable, things of that nature.
Just to quickly add to that, I'm not convinced that a mandate needs to be necessarily established, but it's certainly its best practices. I mean, it'd be in the developer's best interest to take the time to do the right job and get the most, the folks that it will do best by them, and just not best by them, but like offer them the best input. So it's money and time well spent more than a mandate, I think, from my opinion, anyway.
I would just add, I think the Block Island model of involving industry in the monitoring for the project was successful, and I think that should be done, and certainly with these larger projects as part of getting industry involved.
Okay, great. John, I think you had a question?
Yeah, it's still on this same topic. It's, much of the problem that I'm seeing, it relates to the big question that Dave asked earlier, is that you've got potentially 3 to 5 large projects that are going to be going into the water at some point in the near future, all relatively during the same period of time. And the amount of construction that's going to be going on actually dwarfs the experience of Block Island. It's just an order of magnitude different. So you've got these very large companies that are doing their job, and they do it well. And then you've got a whole bunch of fishing businesses that are all much smaller scale, family-sized businesses. So that creates a real asymmetry between the two industries. So the question I've been wrestling with, and I know Rick has been wrestling with it, I think Andy's been wrestling with it, is that how do we bridge that asymmetry? Is there a structure? Is there an institution that doesn't exist yet that the fishing industry needs to create in order to be able to bridge that asymmetry? I'm hearing Lanny, when he's talking about the fishery advisory board, it's something even bigger than that, I think. So I'm wondering if you want to expand on that anymore.
Yeah, I don't know what the answer is. I mean, to me, the Fisheries Advisory Board was probably the most important thing, the role fishermen played in this whole thing, was because that's what what allowed us to have facilitated meetings with the developer to weigh in on all the different aspects of what's going on with these things. And I think that's probably the most important factor. And I know what you're saying, John. It's if you have 3 or 4 of these projects going all at once, I mean, the fisherman side of me says, wait your turn. Direct talks with the developer, like I said earlier, if you come in with the 300-pound gorilla in the room and you're going to try to make the fishing industry collateral damage, chances are you might not be so successful in getting your wind farm up in a timely fashion, because I don't think the fishing industry in southern New England is going to stand by and be made collateral damage. I mean, I think you've got responsible people from the fishing industry that want to work through this process and find a way for us all of us to work together and for everybody to survive.
But back to it. I mean, at some point, it can't depend on voluntary effort from the fishing community anymore. A burnout. How many? You're already talking about how many meetings can I go to? Okay.
I agree.
So, at what point do we stop relying on voluntary effort and try to create the institutions that will drive the fishing industry into some sort of more professional relationship with the wind power companies?
Great idea, John.
I think locally in this state, we kind of have that. We have the Commercial Fisheries Center, East Farm, we have the Research Foundation, and I think those are really two great avenues to start. So locally, you know, and I think, they're both welcoming entities that guys can go to with ideas and concerns, and you know, the fishermen should, some of them, I think, need to be more open-minded with that. But I think here locally in Rhode Island, those are really two good avenues to start.
Chris, you have a question?
Yeah, so Chris McGuire, Nature Conservancy. So this is a little bit of a change of gears, but thinking about bridging between the last session on science and this session, this question is maybe more for Lanny and Rick, but what are the gaps that you guys see in the science and work that's being done and the questions? Because, you know, the researchers were asked, but I think it's probably as important, if not more important, to ask the fishermen, like, what are the gaps you see? You know, if you were worried about impacts on your fishing business, what would you be studying?
I mean, that's a great question, and I wish I knew the answer to it, but there's so many things when you're talking about a food web that it's one small thing that could be affected, some coopod, some phytoplankton, some zooplankton that this thing displaces, and, you know, I'll use my own industry, that affects lobster settlement. There's some new research that just came out that there's a certain coopod, and I won't try to pronounce it because I'll just butcher it, but there's a coopod that's been found to be, when that coopod, certain coopod is in high abundance, is when there's successful lobster recruitment. When that coopod isn't there, lobster recruitment's not so great. So, you know, this is very, very intricate, and I think it's very important. That's why it's so important to get good science as much as we can possibly out of the gate, and go at this slowly. I mean, you know, there was one thing I learned from Andy Gill, which was one of the researchers I think John King's been working with on the electromagnetic field, and a few of the other researchers. It was something else that we learned early on from the ocean sand process. They brought a lot of researchers over from Europe to talk with us, the fishing industry, and the one message that I've got out of it loud and clear was slow down. Because we didn't do it right in Europe. We did it the wrong way. We built it, and then we tried to do science. So, you know, to go gangbusters ahead with 3, 4 different projects all at the same time, we don't know, we have no idea what we're doing. I mean, it's almost, I mean, that was the great thing about having the Block Island project, even though it was so small. We have a chance to look back and start looking at some of the studies we did. Maybe we didn't do them all. And it wasn't a perfect process, but we got a little bit of a handle on it, and I think you can only build on that.
So I'm sure there's a gazillion things that we don't know that we probably should, but specifically, one thing that I think about a lot is characterizing the spatial footprint of the small boat fisheries, the commercial fishing industry and the recreational fisheries. How do we know where these activities take place definitively? You know, we have paper reports that we do that we put one location on them that says that's where we fished, but that's not how fishing works. You don't just fish on one spot, you fish all over. So I think it'd be worth spending some time to better understand exactly where we fish, and that might help inform the sighting process as well as the micro sighting process, and that would be some form of a research thing that I think would be important.
I hear there's an app for that.
I'd just like to add, and this is going back to the presentation that Jeremy had put on earlier, you know, they had 2 years worth of research for the ventless trap survey, and as a commercial fisherman for going on 30 years now, and a lot of the other guys in this room have been fishing longer than I have, they can tell you, just because you've caught something in some place for 2 years does not mean that's the worst place in the ocean to go fishing. Because 2 years from now, that might be the best spot you have for the next 5 years. Always changing out there. It's always changing, so keep that in mind when you try to identify the spot that you figure isn't very good for fishing.
I've seen two more hands.
Yeah, I'd just like to make a comment in reference to John's question about how the industry, as small entities, defend themselves against big companies or work with the big companies. I think that the ocean SAMP process gave us the ammunition to do that. The fishing industry negotiated with Deepwater Wind, and Deepwater Wind came up with a large sum of money to allow the Commercial Fisheries Center of Rhode Island to hire a professional to give us the capacity of being able to send someone to those kinds of meetings. And I think, John, that's the type of thing to get. I don't think that there's much chance of being able right now to go to the government, whether it's the federal government or the state government, and say, give us some dough so we can support ourselves. But if you build that sense of trust that the industry was able to do with the developer, we were able to convince the developer that it was in their best interest to see that the industry had the capacity. Aileen and her company wanted to know that there was some individual that they could reach out to in a timely fashion if an issue arose. And that's the way to do it. And I would recommend that all projects that the fishing industry try to organize themselves, negotiate with the developer to get the developer to fund that capacity. It's in everybody's best interest. Thank you.
Eric Nelson, EPA. North of Cape Cod, there are some known migratory routes for lobsters that move from inshore waters into deeper offshore waters in the fall and winter. And I'm just wondering, in light of this information with respect to electromagnetic field impacts, is there an understanding of similar migratory routes in Rhode Island Sound, Rhode Island waters with respect to inshore versus offshore movement? And are we recognizing, are we seeing a potential barrier to migratory movement through electromagnetic fields? And should this be further studied?
Yeah, it's a great question, and yes, we do have migration that takes place here in Rhode Island. I was involved in one of the research projects for the ventless stuff that BOEM sponsored, and we had lobsters that we had tagged, and I don't know right off the top of my head what the timeline was, but it was like we had lobsters. I think it was a lobster that I tagged, approximately 18, 20 miles outside of Rhode Island. Down in the SAMP area, and within 2 or 3 weeks it showed up down in Maryland, believe it or not. So yeah, they do travel, they travel fast. We have anecdotal studies that, that myself and some of the guys that I fish with have done. We put lobster bands up on their knuckle and we write on them where we caught them, and you can actually watch the lobsters. You wouldn't think an animal like that could move that fast, but I've got a friend that does it was doing it up in the bay all the time, up around the Newport Bridge, and he would catch them there, and sometimes within days I'd be catching them 10, 12 miles offshore. That time of year when the water warms up, it seems to me like they reach a certain size, they get to be sexually mature, and I think you get more settlement coming in, so there's only so much available bottom, and they put their sneakers on and go, And we see it year after year.
So we have time for one last question. If anyone would like to volunteer for that? Seeing none, then let's give our panel a hand of applause.
So, Dave, I have one last question. Where are the drinks? Okay. So now the work begins. There's a bar over across the street where we had lunch, and also heavy hors d'oeuvres and a poster session. So please make your way across the street, and we'll see you here tomorrow at what time? 8:30. Very good. Thank you.